Let's talk about hybrids.
'Electric cars are making big waves.
20 years ago,
But if you can't get to a Tesla charge neutral, and we would use all.
When you learn
Electric cars are making big waves in the automobile world. These noise-free, pollution-free, and high-performance vehicles are expected to make their IC engine counterparts obsolete by 2025. This video will unveil the hidden technologies behind the Tesla Model S, which recently became the world's fastest accelerating car. We will see how electric cars have achieved superior performance by analyzing the technology behind the induction motor, inverter, lithium-ion battery power source, and above all, the synchronized vehicle mechanism in a logical, step-by-step manner. The powerhouse of the Tesla car is an invention made by the great scientist Nikola Tesla around 100 years back, the induction motor. The induction motor has two main parts, the stator and the rotor.
20 years ago, mentioning a Toyota Prius in the same sentence as a Ferrari would have been considered considered crazy, but it shows how far ahead of its time the original Japanese hybrid was when it launched back in 1997. But let's kick off with this fun fact. The current Toyota Prius uses a 1.3 kilowatt hour battery pack, while the Ferrari LaFerrari hypercar uses a 2.3 kilowatt hour battery pack. Both use a petrol engine plus regenerative braking or otherwise lost energy to top up the battery cells that then amp up the electric motor for a performance boost. You don't need to plug them in because the battery packs are about a quarter of the size of most plug-in hybrids and 1/20th of the size of an electric vehicle. Big battery packs are still expensive. Affordable Prius are heavy, which is why Ferrari keeps it refuses to put a 500 kmah battery in a future sports car until the battery weight drops because it hurts handling. But which type of hybrid is best? A series hybrid uses a petrol or diesel engine only to top up the batteries, with the electric motor powering the vehicle, the engine in tandem with the electric motor to drive the vehicle. The LaFerrari is a parallel type because it mixes the 588 kilowatt V12 petrol engine with a 120 kilowatt electric motor. But the Toyota Prius is a series parallel hybrid. The difference is that the Italian hypercar never switches off its petrol engine. It's all as a Ferrari would have been considered crazy. But it shows how far ahead of its time the original Japanese hybrid was when it launched back
of the electric car. Now, let's turn our focus to the battery pack. You will be amazed to find that they are just a collection of common lithium-ion cells similar to those used in your daily life. The cells are connected in a combination of series and parallel to produce the power required to run your electric car. Glycol coolant is passed through metallic inner tubes through the gap between the cells. This is one principal innovation of Tesla. By using many small cells instead of a few big cells, effective cooling is guaranteed. This minimizes thermal hotspots and even temperature distribution is achieved, leading to higher battery pack life. The cells are arranged as detachable modules. There are 16 such modules in the battery pack, constituting around 7,000 cells. The heated glycol is cooled down by passing through a radiator, which is fitted at the front of the vehicle. Moreover, you can see how such a low-height battery pack, when fitted close to the ground level, will lower the vehicle's center of gravity. The lower center of gravity improves the stability of the car considerably. The large battery pack is also spread across the floor, offering structural rigidity against side collisions. Now, let's get back to Tesla's drivetrain. The power produced by the motor is transferred to the drive wheels via a gearbox. As previously discussed, Tesla Model S uses a simple, single-speed transmission because the motor is efficient in a wide range of operating conditions. You can see that output speed from the motor is reduced in 2 steps. Even achieving the reverse gear is quite easy in an electric car. Just change the order of the power phase for this. Transmission is speed reduction and associated torque multiplication. The second component in the gearbox is a differential. The reduced speed drive is passed to it. You can see this is a simple, open differential. However, open differentials have a problem of traction control. But why does such an advanced car use an open differential rather than a limited slip differential? The answer is that the open differential is more rugged and can carry more torque. The traction can be overcome with help of 2 methods: selective braking and cutting the power supply. In an internal combustion engine, this power supply cut by cutting the fuel is not so responsive. In an induction motor, however, the power supply cut is quite responsive and an effective means for obtaining traction control. In the Tesla, this can all be accomplished using a state-of-the-art algorithm with help from sensors and controllers. In short, Tesla Motors has replaced a complex mechanical hardware system with smart, responsive software. Did you know an electric car can be driven efficiently with the help of just 1 pedal? This is due to its powerful regenerative braking system. That means saving the huge kinetic energy of the car in the form of electricity without wasting it as heat. In an electric car, as soon as you release the accelerator pedal, the regenerative braking comes into action. The interesting thing is that, during the regenerative braking, the same induction motor acts as a generator. Here, the wheels drive the rotor of the induction motor. We know, in an induction motor, the rotor speed is less than the RMF speed. To convert the motor to a generator, you just have to make sure that the rotor speed is greater than the RMF speed. The inverter plays a crucial role here in adjusting the input power frequency and keeping the RMF speed below the rotor speed. This will generate electricity in the stator coils, which is way higher than the supplied electricity. The generated electricity can then be stored in the battery pack after the conversion. An opposing electromagnetic force acts on the rotor during this process, so the drive wheels and the car will slow down. This way, vehicle speed can be accurately controlled during the drive using a single pedal. The brake pedal can be applied for a complete stop. As you might already be aware, electric cars are much safer than internal combustion cars. The cost of maintaining and driving an electric car is much lower than that of an IC engine car. With the drawbacks of the electric car abated, through the advent of improved technology, electric cars promise to be the cars of the future. We thank Mr. Jehu Garcia, an electric car expert and YouTuber, for his technical support for this video. Your support at Patreon.com is highly appreciated. It enables us to make additional free educational videos for you. Thank you.
20 years ago, mentioning a Toyota Prius in the same sentence as a Ferrari would have been considered crazy. But it shows how far ahead of us when it launched back in 1997. But let's kick off with this fun fact. The current Toyota Prius uses a 1.3 kilowatt hour battery pack, while the Ferrari LaFerrari Hypercar, why they're not in an affordable Prius, and they're heavy, which is why Ferrari keeps them small. BMW says it refuses to put a 500 kmah battery in a future sports car until the battery weight drops, because it hurts handling. But which type of hybrid is best? A series hybrid uses a petrol or diesel engine only to top up the batteries with the electric motor powering the vehicle. A parallel hybrid uses the engine in tandem with the electric motor to drive the vehicle. The LaFerrari is a parallel type because it mixes the 588 kilowatt V12 petrol engine with a 120 kilowatt electric motor. But the Toyota Prius is a series parallel hybrid. The difference is that the Italian hypercar never switches off.
Of Tesla. By using many small cells instead of a few big cells, the AC power, which in turn will control the motor power output. The only purpose of with help of two methods.
Please, I'm Henrietta Ejim, a computer science lecturer at Finale Technical University, and also a BCDI scholarship beneficiary by Canadian government in the UVs.
Marvin Appiah say the Electrical and Electronic Engineering Department at Finale Technical University and with the Center of Excellence at the institute.
Okay, so I'm Assistant Superintendent of Police, Solomon Awudu, from the Ghana Police Service.
My name is Stephen Okoyefi, STC, Research Officer.
Assistant Superintendent of Police, Ghana Police Service, Emmanuel Kujifosin.
Kafui Ayeto from Kwame Nkrumah University of Science and Technology, and the chair of the Electric Vehicle and Sustainable Mobility Group at the university. I'll tell you more about myself in the afternoon when I do my presentation. Then the other, I'm part of the facilitators. Then the other facilitators.
Francis Eliklibi Altejo, training instructor for Toyota Ghana.
I'm Godwin Rajiv Baby, National Technical Lead for Toyota Ghana and Head of Field and Technical Support.
Okay, and then we have electric vehicle technician from Journal, and then we will have Samson Wishao from Japan Motors, also part of the facilitators. We will be also having Joyce Ukansi from the Energy Commission. She's the project coordinator for the Drive Electric Vehicle Initiative at the Energy Commission. And then we'll be having Daniel Ilsel tomorrow from the Ministry of Transport to talk about national transport policies. This morning, we will also be receiving the Kweku Kalmoni, who is our host here at the Silver Star Tower, to tell you more about Japan Motors and Silver Star Tower this morning. Okay. So, because we don't want to waste much time, okay, I would like to take the opportunity to tell you about this program. If you look at your program outline, we have day 1 and day 2. Sorry, it's a bit small, myself I can see. If you have the soft copy, you can just open it up. So, we have introduction, which we have done. We would like to move fast. Then we will have the experts talk about what electric vehicles are. The program is supposed to be interactive because we have different backgrounds. So you are allowed to intervene at any point in time. That is supposed to be interactive. So you can be asking questions. So the first round, the experts will talk about what electric vehicles really are and then we'll have a health break, that's snacks from 11 or maybe earlier. Then we'll have a show and tell. Ijamo will be bringing some of the electric vehicles. We would like you to enter and look at the dashboards and what they mean, and if you want an experience, you can have the experience. Then it should also show and to tell you the major differences between an EV and internal combustion engine vehicles. Then we will have EV drivers who have been driving it as Uber and Bolt. They will be here. They will stand here for us to ask them questions. So that what we do here is not about theory. They've been driving it for years. What has been their problems? Have they been stuck on the road, or is it cheaper, or whatever? We will leave them to you and myself. Then we'll satisfy. Then the EV mechanic is also here. He will also come in front to tell us about maintenance of an EV, the experience he has had with maintaining EVs. Then there will be another session at 2. That will be the last session for today, where we talk about why the craze for EVs. Why do we even need to move to EVs? We are very comfortable with petroleum fuel. So we will also dissect that and benefits, disadvantages. One thing about this program is that it's supposed to be very realistic. So because the facilitators are engineers. So it's like from an engineer perspective to you. So you decide. So we'll tell you the advantages and disadvantages. We know you are policymakers. In the end, you are going to take the decisions for us, the engineers. So we will tell you the truth, and then you decide what to do in your policy making. So it's going to be realistic. We are not enthusiasts. We are just realistic people. All right. So day 2, we will tackle myth-buster sessions. Are electric vehicles safe? Can electric vehicles leave you stranded? The range, is it true? What is the most efficient speed for driving? Does air conditioning affect the range? Does the EV battery last forever? Temperature? Are EVs prone to accidents? What is the safety accidents? Are they more prone to the accidents or not? We will answer all that technically. Then we will have a health break, then we talk about the charging ecosystem. We have a charging station here, so we will do a demonstration. Japan Motors will do a demonstration of how to do the charging. Then we will talk about some of the challenges of charging in Ghana. The Drive Electric Vehicle Initiative will be coordinator will also be here to tell you about the regulations for charging station, and then we tell you about EVs and the grid. We are expecting some people from ECG to be here. Okay, they are not. Oh, okay. One of them is here. So one of the sessions we'll ask them some few questions about EV and the grid, and then I will show you what challenges people are having all over the world with the grid, the good, the bad, and all that. Then we close. So as you can see, we intend to close early each day. You close, and then after lunch, you are gone. All right. So any clarification on the agenda? Okay, thank you very much. So to introduce you to the Blue Hammond Energy Center and then the Kwame Nkrumah University of Science and Technology. The Blue Hammond Energy Center is the energy research center of the university, so it is part of the university, made up of professors, lecturers, harnessed all over the university, in collaboration with other universities in Ghana and abroad, depending on the program, Germany, whatever. So last year, for instance, our first EV training was for mechanics. That was very technical. So we collaborated with GIZ and then the Urban E-Mobility Initiative from Germany. And we did that at KNUST. So we have many collaborations depending on what we want to do. So for today like this, you see we've collaborated with Japan Motors, Toyota, and Ijano to organize this program. For example, if you take the core technician training program, I'm telling you about this so that in future, if we need training, we can come and do it for you. Because this is just a gem. We have training packages for the police, We have training packages for DVLA, National Road Safety Authority, policymakers, the ministry, and then core mechanics. So for the core mechanics, we have EV awareness certificate training. Sorry about the font. It's a 6-month internship. That is what we did last year. They came for the training and then we sent them to EV industry. We found places for them, took them there, and they served for 6 months, and all of them have been employed at, by the EV companies. Then they have certification 2, high voltage electric vehicle technician. That one, they also come for the training and then they go back to do 6 months internship. The first one is more about safety, because the EV is electricity on wheels. So we train them about how they can protect themselves and how they can protect the company. So certificate 1 is all about safety. Then certificate 2, we go a bit more into inspection and finding faults and knowing how to test them. Then certificate 3, we go more about EV, the battery itself, how to diagnose, how to keep it safe, and all that. By the time they finish, they are supposed to be high voltage EV and battery technicians, able to service electric vehicles, repair them, and then diagnose them. Okay. So we have other courses. We have professional courses such as crash accident investigation and reporting. We did a curriculum for DVLA recently on some of these things. So crash accident investigation and reporting. The police will be interested, DVLA will also be interested. Vehicle testing and inspection procedures. Vehicle damage assessor. So for say valuing the vehicle after an accident for insurance purposes, and fleet management, charging station planning, and all that. Okay, then we have other courses not related to EVs, solar photovoltaic, biogas technology, renewable energy, whatever. So based on the training needs, you can inform us, then we can come and train your institution. Thank you very much. Mr. Bekuka Amoni is here. I would like him to, good morning, I would like him to welcome us since he is our host. Robert.
All right, good morning. Good morning. I'm very happy that you started. What time you started, at 9 or 8:30?
8:30.
Fantastic, I like that. Can I ask the people who are at the back come to the front? Because when we take pictures, they think I smell very bad. And I know I bathed this morning, so I don't smell very bad. Can you move forward, please? Move forward. Okay, for you. Okay, those who have, other people who don't have a problem, you can move forward. I'm your host, I'm the Executive Director of Silversat Tower, Al-Haji Kweku Kalmouni. I like to run and I like to bike, so if you want to challenge me, I'm always open to a challenge, but today we are not here for running and biking, we're here for EVs. EV chargers, I believe. EV is electrical vehicle chargers. And there's a couple of things. Japan Motors, the industry hasn't moved too fast. And I'll come to that point, why there haven't been a lot of electrical vehicles later on. But the course is on electrical vehicles, and I'm happy to say Silversat Tower is the first company in Ghana to have not only an EV charger, you can see it at the bottom there, but a solar EV charger. And I think 3 months ago, the Energy Commission did their own. Is there anybody here from the Energy Commission? Okay, the people at the back, you can move forward, so that the latecomers will not disturb us. So, and this is the way forward. So, and this is problem number one. So we have a lot of gas turbines. So we need to do, I believe, a lot more hydro dams, and Ghana actually can do 10 more smaller hydro dams, like the Bui hydro dams. Then it will make more economic sense, because we are doing this for environmental reasons. We want to reduce the heating of the world and make it more green. So we are here today on these issues. The other last thing is the Ghana government policy. Is there anybody here from customs? Nobody here from customs. Excuse me, do you know the duty on electrical vehicles in Ghana?
Duties on electrical vehicles?
Yes.
Nobody see.
It is 20%. But if you bring a pickup or a small car, it's 5%. So we penalize people for bringing green cars. But anyway, today we are focusing on this. You might ask, why isn't this happening a lot? It's because we have so many problems. And today we're going to solve some of these problems. So I think at this point in time, I'll hand the microphone off to you. I'll sit here for maybe 5-10 minutes for people who have some good questions for me. If you have troublesome questions, political questions, send them to me. Thank you.
Thank you very much. He's been hospitable in hosting us here. We are very grateful. Okay, so do you have any questions for him? Okay, so they have a charging station. They were one of the first to have a level 2 charging station, solar charging station down there. Where I think the general people, you've charged there before, right? Your drivers, okay. So they've been helpful to the country. We'll be demonstrating that tomorrow. Okay, so so the training is supposed to be, for example, tomorrow's training about myth busting is to answer all your questions. I remember we went for an IEA training, and they were very difficult questions. And for example, is it easier for an electric motorcycle to be involved in an accident compared to a regular motorcycle? I think the police will be interested, right? Is the damage higher or lesser? Because I'm aware they are about to use electric motorcycles. Am I right or am I wrong? It's possible. Okay, I heard you're about to use electric motorcycles. And then when it comes to the maintenance landscape, are we able to find parts here? What happens when the vehicle is submerged? There's flooding in Accra, and an electric vehicle is submerged. Electric vehicle fires. Can they be put out with the regular hydrant water? Is it? Can they cause fire at home? Charging. Can they charge the vehicle at home? Can they use the regular socket? Do they always have to go to a charging station? If they go to a fast charging station, does it affect the life of the battery? How do we dispose of the electric vehicle battery? Do we have regulations for that? If we don't, are they dangerous? Can we repair the battery? The battery's cost is like 60 to 70% the cost of the whole electric vehicle. If it is gone, what happens to you? Do we have the batteries in Ghana? Are we going to import them? And then about incentives and taxes, which engineer has mentioned. What are the total cost of ownership? What are the taxes on the EVs at the port? Government announced incentives. Are the incentives working for people? We will mention all that in due course. Some today, some tomorrow. What is government's strategy for electric vehicles? 2030, 2035, 2045, 2060. Ministry of Transport will come and tell us themselves. Chief Inspector, you are welcome. You are welcome. Okay. And then we'll also give you the mic to tell us there are NGOs here. We carefully selected you. The training is strictly by invitation, so we know that you'll find it. STC can tell us they have 10 electric buses, the state of electric buses, and if they are going to buy new ones. I heard you are going to buy new ones, but I didn't see electric buses in them, so I don't know if you have given up on them or, yeah, if you are bringing. What is the charging situation like? What is the EV grid? Net metering. Those who have heard of net metering recently, there is a portal open for net metering. How does it affect electric vehicles? Will it affect the grid? What are the examples of from other countries, China, Norway, Europe, the situation of EVs in the world now? What we discuss. So without waiting much time, let me give it to the EV trained technician to take us through the basics of electric vehicles. Francis.
Good morning once again. Good morning. I want to try and see if the mic is off. I can make it. Is that okay? Yeah. Yeah. I think I have that presentation voice. Oh, I'm caught in the web. Okay, I'm Francis Elikwe Yaltejo, training instructor for Toyota Ghana. For today's program, I'm asked to do just the introduction, and exactly what I'm going to do. So, for EV vehicles, there are the reason why we are here this morning. But EV vehicles do not come just overnight. It started from somewhere. Okay. So this morning we will look at the introduction of hybrid first, then we go to the EV vehicle itself. So in the line of the hybrid vehicles, we'll look at type of hybrid vehicles, we'll look at the system main components, the vehicle lineup, that's type of hybrid vehicles, characteristic when driving the hybrid vehicles, and service point. We'll take out the component details because it consumes a lot of time. Then we'll look at service point. So quickly we take it. If you look at our roads, we have a lot of vehicles. Okay, I am at Toyota head office, and every morning the motorway is packed, and you will be following smoking vehicles. And the way it is annoying when you follow smoking vehicle, your car is not smoking, it's not causing harm to anybody, but the next car in front of you is smoking. And you have no choice but to roll out your glasses. Industries are also emitting a lot of noxious gases, as well as vehicles. So environmental agencies started worried about the harm these noxious gases are causing to us. Okay, so there is the need to do something. So we are in the vehicular industry, so we are much concerned about what vehicle manufacturers are doing about emitting of noxious gases from their vehicles. So we look at gases from the tailpipe. Mostly that is the main emission point on the motor vehicle. Other areas like crankcase ventilation. The engine needs to breathe, and anything that happens on top of the piston happens beneath the piston, except for combustion and explosion. That is, piston compresses up And when it's coming down, it compresses down. The only difference is that the volume beneath the piston is bigger. That is to the sump or the oil tank and the crankcase. So as the piston moves up, pressure is built under it as well. This will prevent engine from moving freely. Do you get it? Therefore, the engine needs some sort of breathing. So crankcase ventilation is created. Crankcase ventilation created is not only the breathing that is there, but the oil heats up and it releases fume. Explosion takes place on top of the piston and pie gases are produced. They bypass the side of the piston ring and get to the bottom. They escape through the ventilation and get to the atmosphere. If you watch some old Taxis, you will see that some hose is let down and a white smoke coming from it. Have you noticed that before? Okay, that is crankcase ventilation gases. Manufacturers put better construction in place where it is rechanneled to burn in the combustion chamber. So that is crankcase ventilation. We have the fuel tank area and carburation system where hydrocarbon escapes into the atmosphere when the fuel tank is not tightened well, when there are hoses that are not well secured, pure fume of fuel goes to the atmosphere. When some vehicles bypass you, you smell fuel. Is that not it? Okay. So we have the evap system or evaporative system that needs to be taken care of as well. Okay. These noxious gases are hydrocarbons, carbon monoxide, nitrogen oxide. Diesel particulate matter has become a big concern to the industry of late. Gas DPF was brought in. We know what the DPF is. Diesel particulate filter. How many of us know of that? Diesel particulate filter. Okay. So we have diesel particulate filters these days on diesel vehicles. It's a filter in the exhaust system. Its work is to take care of the soot or the black substance that comes out of the exhaust. You know how dangerous that is? Are we there? Yeah. Okay, so the filter takes care of this. With time, it gets choked. And there are means to do that. But we have the diesel particulate filter. Okay, then we also have what is not there is a system that takes care of NOx, and that is selective catalytic filter. Okay, take care of NOx. Okay, so all these the manufacturers try to take care of. The auto manufacturers put systems in place, about 8 different systems in place to take care of this emission. We call emission control system on the motor vehicle. Okay, first one we have positive crankcase ventilation to take care of the emission system. Then we have evaporative emission system that take care of fumes of petrol. Okay, and that brought the need of charcoal canister. How many of us have heard of that? Charcoal canister or the canister. Okay, then we have the AF and the O2, what we call oxygen sensors. Okay, we have 2 types of oxygen sensors that also take care of the closed loop system they constantly monitor the burning or the exhaust gas that is going out, and they judge whether the burning takes place well or it did not take place well, whether there's more fuel or less fuel. Are we getting it? So the oxygen sensor reports to the control board. I prefer to say control board so that we can understand, or engine control module, or power control module, or ECU. Okay, I want to mention all the jargons we know for it so that all of us can understand what I mean. Okay, so the oxygen sensor tells the engine ECU the oxygen concentration in the exhaust. So it's able to judge how much air is coming and then inject or command the right proportion of fuel. Are we getting it? So that we will not have too much fuel in the exhaust gas. And then we have the secondary air injection system. Is another system that pumps air into the exhaust gas that is going out. And then we have the EGR, exhaust gas recirculating system, that allows small portion of exhaust gas to go into the combustion chamber. Its work is to control the combustion temperature. Are we there? When the combustion temperature is so high, NOx is generated, nitrogen oxide is generated, and that is a harmful gas to us. Are we getting it? So to control the generation of nitrogen oxide, exhaust gas recirculating is introduced. Then we have the three-way catalytic converter, the one our friends like stealing a lot. The police told me the other day I was teaching at the police head office. They say it's called cocaine. Okay, so people like to steal the converter a lot, but that is the three-way catalytic converter. Its work is to take care of carbon monoxide, hydrogen carbon, and nitrogen oxide. That is coming out from the engine. Are you getting it? So that it's able to convert them to carbon dioxide, water, and oxygen. Are you there? Okay, so that is the work of the catalytic converter. Then we have the diesel particulate filter, I mentioned it already, and we have the selective catalytic reduction. That is taking care of NOx as well. Even though we have EGR there, it controls the NOx generation. It does not mean that nitrogen oxide is not generated, especially on diesel. Diesel produces a lot of nitrogen oxide. I hope you are there. Okay, so on motor vehicles, diesel, especially for big cars, the selective catalytic reduction is introduced. The main component there is what we call AdBlue. How many of us heard of that? AdBlue. Oh, we have not heard of AdBlue. Wow. Or a urea. Okay. AdBlue is a trade name of the main substance used in this system. It is another fluid, not fuel, that is actually used, and it is sprayed into the living exhaust, the burnt gas that is going out, so that it will neutralize the nitrogen oxide in the exhaust gas to nitrogen. I hope you are there. Okay, so these are the efforts automakers put in place to control emissions from the motor vehicle. If we are able to take out all the noxious gases all the harmful gases, and we have a perfect system on the motor vehicle. One gas that cannot be taken out, even though we can control it, is carbon dioxide. Carbon dioxide. Okay. As we all breathe in and breathe out here, we generate carbon dioxide. Is that not it? So even in our meetings here, carbon dioxide is generated. How much more where heavy heat is released? Okay. So the environmental agencies and automakers are thinking of ways to reduce also carbon dioxide generation. And that brought the need of eco cars. That brought the need for eco cars, of which electric car is the champion today. Are we getting it? Okay. So energy consumption over the years going towards 2030, fuel price is going up every day, more vehicles are being made, and more fuel is burnt every day. Okay, I burn about 85 liters of fuel every 3 weeks. That is the size of my fuel tank. Because I do a short distance from Accra New Town to motorway, and maybe to church and some few rounds in town. Are we there? But maybe the vehicle you use also 90 liters or 85 liters, but you may burn it within a week, depending the rounds you do. Okay, so we burn a lot of fuel, a lot of energy consumption. And so there is a need to curb this consumption trend. Okay, and that is taking us to the eco car area. And also global warming. As more carbon dioxide is released, it retains heat. So we have a lot of global warming. If you go to bed, the room is hot because carbon dioxide contains the heat and releases slowly. Are we getting it? So global warming is another big concern. And the way to go is to reduce burning of fossil fuel. And so there are many Kaizen or systems introduced to control the burn of fuel. Compressed natural gas, synthetic fuel, biofuels, they are alternatives that were produced or found for fossil fuel. Then we come to the line of diesel vehicle. The latest we have today is common rail. I think all the manufacturers are now going common rail because it is a direct injection combustion chamber. And the fuel there in this system burns more thoroughly than indirect combustion chamber. Sorry if you don't go in line with the auto terms, but that is the area where burning takes place inside the engine. We have two types, especially for diesel: direct combustion chamber and indirect combustion chamber. Direct combustion chamber, the burning takes place right on top of the piston. And indirect combustion chamber, the burning takes place in a recess and then transferred down to the top of the piston where explosion takes place. Are we there? Okay. This explosion is very important. That's what keeps your car going. Okay. So we have common rail. We have the DPR, diesel particulate reduction, diesel particulate matter reduction. We have DCAD, diesel control, advanced technology. Then we have the D4S. We have the D4. These are direct four-stroke injection system on petrol engines. We have the VVTi and lengthening. They are all alternatives developed to better control the burning of fuel so that we don't have too much emission into the atmosphere. Then, of course, we go to EV vehicles. Okay, and these are the early alternatives that were in place. Then we come to the EVs. Okay. So to better reduce the noxious gases or take them out completely, EVs were developed. So we have, let me say, different types of EVs, or better still, two main types. We have hybrid electric vehicles, and we have battery electric vehicle. Okay. So with hybrid electric vehicles, we have plug-in hybrid electric vehicle, mild hybrid electric vehicle. Then we have another sort of electric vehicle that is not BEV and is not HEV, and that is fuel cell electric vehicle. It's a type of electric vehicle that uses hydrogen. Okay, I'll go a little bit to that. So with the hybrid vehicle principle of construction, we have series hybrid vehicle. With series hybrid vehicle, we have motor and engine. Basically, the engine is like a generator we have in the house, or you carry a generator, put it in the car, and start it and plug it to a motor, and the motor is driving the vehicle. That is how it looks like. So we have engine there, all right, that is operating a generator. Okay, that's operating a generator. This generator is connected to an inverter. An inverter is a device that converts DC current to AC. Okay, so it operates, the engine operates the generator, and DC is generated. The DC is converted to AC to operate a motor that drives the vehicle. Do we get it? Okay, and that is series hybrid system. Then we have a parallel hybrid system. And so when we say parallel, two things are moving together at the same speed, the same force, and the same direction. Okay, so we have the engine and we have motor. Both sort of driving the engine at the same time. So they share their force. Okay, they share their force 50-50 maybe. When we come to a real parallel hybrid, what we call mild hybrid, I'll show a video of one of them. The motor actually assists the engine, but during the time of assisting, both of them drive together. Do you get it? When more power is needed, when you are climbing a hill, the motor comes in and assists the engine. so that you don't burn too much fuel. I hope you get it. Okay. Then we have a system where the two are put together. And we have parallel series or series parallel hybrid. That actually gives birth to the actual hybrid vehicles you see on roads today. Are we there? Actual hybrid vehicles you see on roads today. Where you have engine, a generator, the inverter, and that mimic the series. I hope you get it. Then you have the motor, and through a power split device, the two of them, motor and engine, can drive the vehicle when necessary. But mostly, the motor alone drives the vehicle. Are we getting it? The motor alone drives the vehicle. With hybrid vehicles, the motor mostly drives the vehicle. When you start, the motor is the one that starts. With hybrid vehicles, you don't hear chong, vroom. There is no starter motor there. Are we there? Okay, the generator acts as a motor to turn on the engine when necessary. That is when there is a need to assist the motor, and when battery energy goes down, the engine will come on to operate the generator and to charge the battery. Are we there? And then the engine will come on and through the power split device assist the motor. And that is actual hybrid principle. So marrying series and parallel together, we have the hybrid system that comes with a quiet operation system. We have a signage drive. You have a generator that charges the battery, and combination of motor and engine gives more powerful driving. It also gives us a regenerative system where motor can charge the battery during deceleration. I hope you are there. Okay. And so we take them one by one and throw more light on them quickly, then we go. We have the mild hybrid. Okay. That is, we say mild because it's on a quiet or a low profile. Okay. Okay. So this one, I will use a Toyota system to explain this, but in other systems, you have a small motor in the area of the freight wheel. Okay, I hope you know where the freight wheel is. At the tail of the engine where, okay, don't mind me because I'm saying auto too much. Okay, I'm an auto bias. Okay, so we have on the Toyota system a motor that is in place of the alternator. That is to say, this car is Toyota Hilux, the latest you see on the road today. Okay, but there is a type that is a mild hybrid. Okay, it has a motor in place of the alternator. It does not have actual alternator, and this is a 48 volts motor. A 48 volts motor. And it has a 48 volts battery somewhere under the seat, the back seat. Okay, and it's located there. This motor is operated to charge the 48 volts battery where the battery energy goes down. Okay, so it is also a generator to charge the 48 volts battery. But it is not an alternator to restore the auxiliary battery energy. It is not an alternator to provide electricity for other accessories on the vehicle like we have in the case of ordinary alternator. But when you see it, it is in the place of the alternator, just like you see on. So when we put two Hilux here, the physical features, they are the same. but powertrain, there is a difference. I hope you get it. Okay, this type operates like this, a small video. So it's a 48 volts system.
The 48-volt system combines a conventional diesel engine and a compact, lightweight unit operating at 48 volts, comprising a new mild hybrid system. Compared to vehicles equipped with conventional stop and start systems, this vastly enhances engine starting performance. Additionally, the system offers the fuel efficiency and water crossing performance equivalent to that of conventional vehicles, while the motor assist enhances driving performance. The 48-volt system is composed of 3 units added to vehicles with engine.
So we have this DC converter.
It includes a 48-volt motor generator that replaces the conventional alternator,
okay, over here.
a 48-volt battery, and a DC-DC converter that controls those other components. The Toyota hybrid system consists of 2 motor generators, an engine, and a battery. In contrast, the 48-volt system is a smaller, more lightweight, compact system that can be fitted to existing powertrains, with a structure that allows water crossings by electrified vehicles as well as conventional vehicles. The assist to diesel engines equipped with this system contributes to comfortable driving performance and enhanced fuel efficiency. Even in city driving and traffic jams with repeated starts and stops, vehicles equipped with the 48-volt system can provide a more comfortable driving experience. Generating more torque up to high RPMs than conventional gear-driven starters, the 48-volt motor generator uses a belt drive to restart the engine, providing quiet engine restarts without use of a gear-driven starter in a system that produces a smooth response with minimal vibration. In vehicles equipped with the 48.
So we have, that's the mine hybrid system. One big advantage it has is at traffic lights or any stopping instance where you stop, normal vehicle engine will be idle, isn't it? This one engine will go off. It's a stop-start system. Engine goes off. But as soon as it is green or you're about to move and you go to D and bring your legs to the accelerator, it responds quickly. Are you there? Okay, so that is one big advantage we have. Then we have the actual hybrid system where we have engine, a motor, a gasoline tank, and a battery. Okay, and a battery. And like I said, they can be synergy drive. That is, they operate, they synchronize each other's strength. The motor alone drives most of the time, but when needed, engine comes in to support. I hope you get it. Okay. Then we have plug-in hybrid. We have plug-in hybrid, where the vehicle operates most of the time as an EV or BEV vehicle. Okay, most of the time it operates only on the motor. Okay, but when the battery energy goes down, the engine comes in quickly. This means that maybe if you are driving from here to Kumasi or better still my home Kampando, okay, maybe you can use just 2 gallons. That would be about 8 liters of fuel. Tukwando and Cap. Okay, because the system operates more on battery. However, what will be your problem is you may not have a charge at Kwando and you may have to tow the car. But you see, one thing good about plug-in hybrids is, and that is where Toyota is pushing towards. People are worried why Toyota is not EV, and Toyota is slow. Drive and charge is the policy. Don't stop and charge. You are going to Kumasi, you don't need to stop at Lindador and charge. You can continue where your battery falls down. So plug-in hybrid is, it has the advantage in that area. Are we there? Then we have various types of plug-in hybrid. Just last month or this month, BEV released their latest plug-in hybrid, BYD. Okay, that is the champion of Chinese EV vehicle producer. Okay, that is build your dream, BYD. So they released their latest plug-in hybrid. Toyota is a champion of hybrid vehicles. Okay, and we have a number of them. Nissan is a great champion in also hybrid vehicles, and we have the Nissan pickup hybrid here. You have the HV battery here. You have the fuel tank here, and you have the power control to the engine and the motor. I hope you are there. So we have Nissan also there. Then we have fuel cell. Is another electric vehicle that doesn't use engine, and so it is not hybrid. Are we there? It's not hybrid. However, it needs a sort of fuel that is hydrogen. It is not BEV that rely completely on battery. Okay, that you need to stop and charge. With this system too, you don't need to stop and charge. You have hydrogen tank there under pressure, and then you have a fuel cell stack here and oxygen. We know that when hydrogen and oxygen meet, water is produced. Okay. What we may not know is that electricity is produced as well. So when oxygen and hydrogen meet in the fuel stack, electricity is also generated. Okay. Water is generated as well, but a good way is found to take the water out. So the only emission of this type of vehicle is water. Okay, no carbon monoxide, because burning is not taking place. We have another type of hydrogen vehicle that burns like how petrol burns, but that is not this system. This system is electric car. Okay, it has motor in the e-axle, okay, or the gearbox, as you put it that way. It has motor in it like hybrid vehicles and electric vehicles. Okay, but each power source is from the fuel stack where hydrogen and oxygen meet to generate electricity. This electricity is used to operate the motor directly. It's also used to charge a battery for electricity storage. I hope you get it. To operate the motor. And that is the fuel cell vehicle. Then we come to the champion for the day, and that is the BEV, battery electric vehicle. Okay, where you charge, and you have enough power stored, and then you start to drive. The EV drivers are here, they will tell us more about their experience. How long you can go before you need to recharge. Okay, and that is the EV. We'll be talking more about that. So we have the hybrid vehicles. We can have the battery of 201 volts, but the powertrain voltage is about 650 volts. Today, powertrain voltage, Tesla has achieved as much as 1,000 volts. Okay, powertrain voltage. And some EV vehicles are doing about 800 volts. Are we there? And that is AC. That is AC for the motor. So it means that you cannot have, and you don't need to have the hybrid battery of that large voltage. Okay, because we have converter inverter there, or a booster, that will raise the battery voltage to this much. Okay, to operate the vehicle. So you don't need to have the battery voltage so much. And so we have the main components of the hybrid vehicles: engine, the auxiliary battery, and the main battery. You have the power cable, a power control module, and you have the inverter and the booster assembled, and the transaxle. Inside the transaxle, we have the two motors and generators. They are motor and generator at the same time. The MG1 is a motor to start the engine when it is needed. With hybrid vehicles, engine don't start from starting. As soon as you press the button or you turn the key to start, you will see ready written on the screen. And once you see that ready, you don't hear any sound. Motor don't start spinning immediately until you bring your leg. So you are not losing power, you are not losing battery power, you are not losing fuel. You hear the ding, but as soon as you bring your leg, the vehicle starts moving. That is a big advantage of induction motor. Are we there? We'll be talking more about that. Okay, then we have, so it's a motor to start the engine. At the same time, it's a generator to charge the battery. Okay, then we have the MG2, which is a motor, the main motor that is propelling the vehicle until the need for engine to start to support it. Okay, and that is MG2. Okay, so we have the system layout, the same thing, battery of this voltage, the power management, and then the inverter converter AC. Inside there also we have DC-DC converter. The work of DC-DC converter, on hybrid vehicles and e-vehicles, we don't have alternator. However, the auxiliary battery or the 12-volt battery is still there. Are you getting it? On e-vehicle, we still have 12-volt battery. And the 12-volt battery will deplete with time. You get it? So you need to charge it. Its work is to take care of the lightings, combination meter, and all those other auxiliary things, not the powertrain. So you need to charge it. So we have a DC-DC converter that steps down the 200 volts to about 14 volts, enough to operate the auxiliaries on the vehicle. I hope you get it. Okay. Then we also have some other systems like power steering. On electric vehicles and hybrids, The power steering is not ATF pump. It is a motor. Are we getting it? And it needs electricity. Even on IC vehicles these days, the power steering is a motor. Okay, it's a motor. Then also water pump. So I'm mentioning things that are belt driven. Okay, because on hybrid vehicles, engine is not always working. Engine goes to sleep until that time when battery energy is down, or until that time when more power is needed, then engine wakes up. Because engine is not always operating, there's no belt to drive alternator. There's no belt to drive water pump. There's no belt to drive power steering. I hope you get it. All these things take their power from the DC-DC converter. And also, you know, the air conditioning needs belts for the compressor. But on hybrids and e-vehicles, because engine is not there to operate these things, there is a need to supply it power. I hope you get it. So the DC-DC converter, in some cases, the compressor is using the HV battery or the EV battery source directly. But in some other small cars where the compressor does not need that much power, it goes through the DC-DC converter. I hope you get it. Okay. And so we have the layout for different types of vehicles. Some of them uses, they are 4x4. Okay. So there is a motor in the rear axle. Okay. In the rear axle, where we normally have the crank, the differential over there. Okay. There is a motor there to take care of that. Because in this system, there is no transfer case, okay, or 4x4 gearbox. Let me put it that way. You will understand it better. I hope you are there. So we have motor there for the 4x4 system to take place. And that is hybrid. So this video will just consume our time because it was played before if you were watching. Okay. And then we have different types of the hybrid vehicles over the time. We have manufacturers. Toyota is the champion of hybrid vehicles. However, others, Honda, Ford, Hyundai, Kia, BMW, Mercedes, Nissan, and plenty of them are there. Okay, that also manufacture hybrid vehicles. Advantages are better cost retain. Okay, in terms of fuel cost, you save so much as compared to the same type of vehicle over a time of owning the vehicle. It produces less emission, therefore better green atmosphere. Okay, then they are mostly automatic, comfort drive. No nitrogen is generated, no, or even if there is a generation, it's very less because engine is still there. It's very less. If you take one hybrid vehicle, the NOx generated will be up to about 29 non-hybrid vehicles. Okay, you save a lot of money. And if you drive in Europe, you will not be charged for emission. Okay. Then you get a residual value. Maintenance cost is very low when you own hybrid. They have good towing capacity. They can be driven as EV, especially with plug-in hybrid, for a long time before engine comes in. And owners of hybrid vehicles, I'm sure Prof. KNUST is here to give us some brief this thing on owning hybrid vehicle. Are we there? Okay. Characteristic when driving hybrid vehicle. Okay, like I said earlier on, when you start, don't hear anything. You only see ready on the screen, and that means the vehicle is ready to go. You put it in D and you are good to go. You are good to go. The vehicle can run on motor alone for a long distance, especially for a plug-in hybrid. Okay. The battery charge decreases with time, so it needs to be recharged. And then the engine and motor stop. When you stop, everything goes off. You don't lose battery power and you don't lose fuel. Okay. And when driving, like I said earlier on, when you start, motor and starts, and when needed, engine comes in to assist. When descending or anytime you step on the brake to come to a stop or descending, a regeneration or a way where the motor turns. You know, the induction motor, the rotor is magnet. So as magnet rotates in principle of electricity, okay, as magnet rotates in loop of wires, current will be generated in that loop of wire. I hope you get it. So when you are descending, motor at this time is not driving. Instead, it is rotating freely by means of the wheels. I hope you get it. By so doing, the motor which is driving the car becomes a generator. And that is the regenerative principle we are talking about. Or where the car itself generates some small amount of electricity. It depends on how the gradient is, okay, to recharge the battery. I hope we get it, okay. And that is the principle of. And that brings us to the end of hybrid service points. We worry about servicing of the hybrid vehicle and electric vehicle as well. Okay. When servicing, this one is for mechanics anyway. You should be careful because high voltage is there. Even in our homes or in the buildings, we have in Ghana 240 volts AC is that. Here we have as much as 650 AC. I said earlier on that some of them have as much as 800 volts and 1000 volts. Powertrain voltage, not the battery. Okay, powertrain voltage. So you should be much cautious about the presence of high voltage. Even with the battery, you have as much as 200 volts DC. And if it passes through you, we may sing different sound. Okay, so you should be very much aware. So you disconnect the negative terminal of the auxiliary battery to put the system off, remove the grip plug, what we call service plug. Each car has different location where it is. And when you remove that, wait for 10 minutes because the system have high capacitors that stores a lot of voltage. Okay, they have high capacitors that will store energy for about 10 minutes. So after removing the service plug, you have to wait for about 10 minutes. Where it is? It ran away. For about 10 minutes before you start to work on the high voltage areas. Okay, if not, you are still in danger. Okay, take note of the type of colors for the hybrid, for the high voltage areas. It's always orange. Okay, it's always orange. And then be careful because high voltage is around. Okay. So you can use multimeter to confirm that the power is completely discharged before you start working on it. Use insulated tools purposely designed for electric vehicles, especially in the high voltage area. Don't use the bare metal spanners we use. You are putting yourself in a big danger. Okay, because this is a high voltage system. Okay. A small video here on how dangerous the high voltage could be. So this is a person working on the battery of a hybrid. The voltage is as much as 229 or 30 volts. And so when using bare tools like this one, bare metal tools, if you are not lucky and it touches positive, negative, in a second, I hope you understand. That's what will happen. So you should not use just a bare metal tools. Wear gloves, protect yourself. The service plugs each vehicle have where it is located. Remove it and keep it, put it in your pocket so that you will be safe. If not, somebody will go and connect it once you are working it. And before you know it, we'll sing different songs. Are we there? Okay, so the battery, if you park hybrid vehicles or electric vehicles for a long time, okay, battery naturally drain. Battery naturally drain. So you should not leave the vehicle for at least 3 months without charging it. If not, you will come and there will be no power at all. There will be no power at all. So at least start the engine once or twice every 2 months, 3 months to restore energy for the battery. Okay. In case the energy drains completely, there is a way to start to recharge it. Okay. There is a charger for it. Even though hybrid, okay, then when this one was, electric vehicles were not there yet. So charge this thing, but this was already developed and it can be used to recharge the battery in case it fully drained. Okay. At one point when hybrid vehicles started pouring into Ghana, we don't have this sort of charger. So I personally developed one. Yes, I personally developed one. And I was using it to take small seeds. Okay. So, and I work on hybrid vehicles a lot. Okay. So if you will have one, please. Okay, so my colleague will be talking about the handling of the EV batteries. Okay, it's very important. Okay, we have the nickel battery, we have the lithium battery. All of them today, hybrid and EVs, are lithium, and we'll be talking much more about handling them. Okay, so I'll leave that one. The auxiliary battery as well must not be left on for a long time. The same thing will happen. So at least run the engine to start it. Okay. You should not use hybrid car to jumpstart another car. Another car can be used to start hybrid car. That is selfish. But you should not use hybrid car to jumpstart another car. The reason is it's not using 12 volt battery directly. It's using DC-DC converter to pass voltage to charge the auxiliary battery. I hope you get it. And the amount of current passing there is higher than the normal vehicle battery. I hope you get it. So if you use the hybrid vehicle to start another car, current of about 600 amps may be passed, and that starter motor is gone. I hope you get it. But you see, you can use another car to start hybrid vehicle, because this time you are not going to start that car. If you start that car, you will start it before coming to charge and restart the hybrid vehicle. So engine is already running. You are not going to crank again. I hope you get it. So you can pass the 12 volts to the auxiliary 12 volts on the hybrid car or the EV vehicle. And then you have the ignition on. Once the ignition comes on, you can go to the ready mode and to drive the vehicle. I hope you get it. Okay. And the battery can be recharged, and as I said, you can jumpstart hybrid, but you can use hybrid to jumpstart another car. Don't tow EVs and hybrid vehicles, especially on the powertrain wheel. Well, I said the powertrain wheel, it can be a 4x4 EV. That means motor is here, motor is here. It can be a rear wheel drive EV. That means the motor is at the back, but the front is only supporting. That's like we have normal rear wheel drive. It can be, most of them are front wheel drive. Most of them are front wheel drive. So the motor is at the front. Okay. I said earlier on that it is induction motor. It is induction motor. Therefore, as the rotor rotates in the stator, current is generated, and heat will be generated. A lot of heat will be generated. Electricity may be generated. I hope you get it. And that can result in fire. So it is preferred you carry it. You don't pull it along. I hope you get it. Okay. So get a type of towing truck that can carry the car, and that will take much more. That brings me to the end of hybrid. Any question? I'll quickly go to the other EV. But any question? Yes, your hand was going out. You ask question. I'm here.
Okay, I have a question.
Yes.
So you were giving us the difference between the full hybrid and the plug-in hybrid.
Mm-hmm.
But the explanation was not very explicit because I want to understand. Yes. I want to understand why a full hybrid is able to charge the battery, but then there's a need for a plug-in hybrid.
That's a very good question. That's a very good question. A full hybrid is able to charge the battery. However, the battery is not able to last for too long. I hope you get it. And the engine will have to come in often to charge. The full hybrid initially were all nickel metal hydride batteries, which is not able to sustain energy for long time like lithium batteries, lithium-ion batteries. You get it? Okay. So because the lithium-ion battery is able to sustain energy for a long time, when you charge it, like EV, you have EV vehicle. Okay, it's purely EV vehicle. And you charge it, it can take you for about, say, 400 kilometers. Then you have not reached Sunyani yet. Okay, and where you have reached and the power comes down, you hit from Accra all the way to Kumasi. The only place you see a charge is KUST. And that charge is very slow, it will take you 3 days. Sorry. Where is Prof? But I know it's level 1.
You can
okay, I'll talk about that one later. Okay. Okay. So you need to charge. Okay, that's why the manufacturer comes in with plug-in hybrid. Drive and charge. You can also charge to have your experience of your normal EV. And also, because the battery lasts for long, engine comes on only when it is needed. So the whole goal is the reduction of emission. The reduction of emission. So plug-in hybrid is able to sustain the energy for a long time before engine comes in. And that is it.
Okay. I have two other questions. So, in the introduction, you explained that the current ICE vehicles, there are technologies that have gotten to a point where most of the emissions are carbon dioxide.
Not only carbon. Yeah. I said that carbon dioxide cannot be completely taken out. It can reduce, but cannot be completely taken out. Like all the cars that are coming these days, manufacturers will come with the percentage of carbon dioxide emitted.
Yeah, so what I want to understand is why are we, because I understand that plants takes in a lot of carbon dioxide. So why are we not promoting more of plants?
Planting more trees.
So, or are you able to give us some statistics that is able to show that the amount of carbon dioxide we are generating, even if we plant a certain number of trees, it still cannot be able to absorb all those carbon dioxide.
Especially in Accra.
And my final question will be, you mentioned fuel cell.
Yes.
Is there any typical vehicle that you can mention that uses fuel cell, or that has not been put into production yet?
Oh yeah, we have fuel cell vehicles that are put into production. So we have the Toyota Mirage. We have the Toyota Mirage, and then we have, what's the name of the bus? I forgot the bus. But I've been lucky to drive the Mirage whilst in Japan. Okay, whilst on training in Japan, we have the Mirage, and then we have the another one. I forgot the name. And just I was reading something, just yesterday. Toyota is producing a high version of the Mirage for the Australian market. So from 2026, a new Mirage will be sold in the Australian market. So we have the Toyota Mirage. I don't know about other manufacturers. I know, yes. Hyundai also have, I forgot the name, but they also have a fuel cell vehicle. And maybe others, manufacturers will come up with some, but if it does not really match with cost, it will not produce much of it. But there is a review.
So currently, what is the focus of most of the manufacturers? Is it on hybrid? Is it on fuel cell and why?
Okay, fuel cell is a bit behind because hydrogen extraction is a lot of cost. Okay, because of a lot of cost, hydrogen or fuel cell vehicle may still be slow in production. However, EVs, BEVs, purely battery vehicles, is hot. Manufacturers are championing, even though Toyota is still pushing for plug-in. Okay, Toyota is still pushing for plug-in. However, Toyota is also producing BEV vehicles. So it's looking like BEV vehicles is the future. However, plug-in vehicles will be there. Maybe we'll even overtake. Okay, unless we have, somewhere last year, Ethiopia announces that from this year there will be no IC vehicle imported into their country. Trust me, they are still selling Ethiopia is just like Ghana, their economic and all, their growth and all those things cannot support what they want to push for. Okay, so EV is promising to be the future. However, I think plug-in vehicle will go hand in hand. And then talking about the absorbing of the carbon dioxide, you see, somewhere, I think it's about 7 years ago, Toyota, we went to plant trees at that field opposite Kolebu Mall, the mortuary. See, where the Sodom Gomorrah has now extended and take it over. We planted 50 trees there. It was a big celebration. I think it was in collaboration with Joy FM or something like that. And we drink and eat that day for that tea. Go there and see. Last time I saw somebody is wearing camel and horses. Didn't you see that? Okay, so that is a problem. Plants, it may not work. And as long as Ghana will use charcoal in killing our industry of forest and now Galamsey. So, no. Yeah. Another question else I move on.
Yeah, yes. I want to ask, Ghana, are we really ready for these electric vehicles? Because this morning we heard that even if you are importing such vehicles, you're going to pay about 20%. And you also mentioned, like, whilst moving from maybe Accra to Kumasi, you have to get to KNUST before you can charge.
But then they'll tow your car.
Meaning the charging stations are not there. Because I remember recently
So doctor, we'll talk about that then. So my colleague and doctor will talk about that. Thank you.
I want to know, with this kind of system, what is the service interval?
Okay. You want to say that well? Okay, all right. So service intervals, like we have 5,000, 10,000, and 15 and the rest for IC vehicles. What will be the service interval for this one? Okay, with hybrid, we have 10,000, because engines don't really count on so much. So engine oil replacement, oil filter replacement, air cleaner replacement is not that much, okay, but you still need to inspect brake pad, you still need to inspect especially air cleaner because of dust, okay, so you cannot keep more than 10,000, okay, so maintenance interval is 10,000 kilometers, or better still, 6 months. 6 months. But for EV, yes, still inspection is there. There's no oil replacement, but we use this cooling system. Okay, so let me do the presentation because I have something small. All right. Yes, boss.
Once you find out, no, if you have a let's say battery consumption or platform consumption, I'm going to this distance. You can calculate, okay, this engine is using 4.6 today. It's the same calculation. You can do that for the okay. This is the amount of battery or the voltage I have. I can use it to cover this amount of distance.
That's a very good question. Okay. He wants to know. So where is the mic? He has finished asking the questions. You see, maybe I forgot to use my mic. Okay. He wants to know, we have 4 tank capacity. Okay. Yes. And I know that if I'm going to Bando, okay, I will burn about quarter of that tank. That tank is 85 liters. So quarter of it, well, the mathematicians, you can tell I can tell how much fuel I will burn. Okay. If my battery is full charge, how much kilowatts will I lose when I drive from here to Bando? I think that's your question. Okay. Okay. There is a gauge on the combination meter. I'll show that right now, which you can, because you have been using the vehicle, you know how much fuel you can use from here to there. You can still be able to tell. The same calculation we use for fuel consumption, that is kilometer per liter times 100 or 100. The same calculation is used here to be able to derive how much fuel you will be able to use from, and how much power would you lose from here to here. Okay, something small like that is in the slide, because doctor will be doing charging. Okay, so I don't want to take it away from him. Okay, all right. Okay, so let me move on. So climate justification is still about the emission and all those things I talked about. So we'll not talk so much about it again. Then we'll go to global manufacturers of EV, and then history and the efficiency and advantage of EV. Quickly we take it. So we spoke about these ones already. What brought the need for EV vehicles, and all that were put in place before finally today we are having EV vehicles. Okay, and like I said earlier on, we can control all the other emission systems. So motor vehicles have emission control system. However, CO2 is hard to go up. CO2 is hard to go up. So alternatives perhaps is the EVs. Even that, CO2 is not gone. Yes. So even though we are saying it's zero, it's not complete. The motor generates a lot of heat. The inverter generates a lot of heat. So we have cooling systems there. But this one is down to maybe about 0.29 or point something. Okay, it's not completely zero. However, we are gearing towards 2050, and everybody is praying that by 2050 we will have zero emission from the road. Okay, when we have traffic jam like this. You see, we are expanding the motorway. What I fear is this. The expansion does not mean that the traffic will flow. Expansion means that it can take more cars. I hope we get it. It means it can take more cars and something like this. Okay, and so that is not zero emission. So our prayer is that if we have more EVs, then the emission will be way near zero. Okay, and that is the goal for. And so we came up with different things, and hybrid, plug-in hybrid, fuel cell, and then the EV. So EV vehicles, like we said, run on batteries. They are plug-in charge vehicles. So you plug and you charge. Once you have enough electricity, you drive. They are very quiet. All you need is to be pressing and you are going. There's no vroom, 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 vroom. Okay. And they are. Okay. When I think the first time I drove one is when we conducted the training in TUSD. So I have a chance to drive one. But you know what I do these days is I have to drop my car and take Uber or Yango somewhere. I make sure that car is EV so that I can feel it. And that is what I've been doing to feel EV. Maybe Madame will give me her own to experience, because when I saw her at the car park, I really envy it. Okay. I mean it. Okay. So that is the EV vehicle. EV started way long. You know, when we were also young, we were practicing Kumpo cars, not tin cars, and hard cars. And we put battery in them and we get motor. And we were so happy about those cars. We didn't know, like by now, Ghana will be the first to bring EV vehicles. Okay, and that is exactly what Robert Edison did some time back in the 1830s, and he came up with the first rough EV vehicle. Okay, even though it was a prototype, if you like, but it was not really on road. Okay, then William Morrison comes with actual EV vehicle, but it was DC motor. And it can attain maximum speed of 22 kilometers per hour and can carry about 6 people. And that was the first successful EV vehicle with DC motor. This means that you need to pack a lot of batteries, and there was no converter, no booster, it was direct. Okay, and that was that. If you look into our system, we have been practicing some things like that on bicycle. We give it car battery and some motor, and we are going. Okay, and that was it until 2008, when Elon Musk started coming up with the real type of electric vehicle based on Nikola Tesla's induction motor. So I think because Elon Musk wants to give some recognition to Tesla, it gives the name Tesla. Okay, but that doesn't mean Tesla produces electric cars. I hope you are getting it. His principle of induction motor is what gives birth to the real electric cars we have today. I hope you get it. And that is a bit history about how electric cars started. This video was
Electric cars are making big waves
today, so I will have to jump it. And it's a fine video. When you find it, you understand EV vehicles much. Okay. So we have a lot of manufacturers. Tesla, like I said, from 2008 comes with the real EV vehicles, even though it started with some challenges. They are developing, and today we get better ones, and other countries and other manufacturers start to give him competition. Okay, all right. Then we have, they come up with these models, the Model S, Model 3, the S and the Y SUVs, they come up with those ones. Nissan have these ones earlier on, and they even have better ones today. Okay, they even have better ones today. VW have these ones, Subaru, BYD, we have Stellantis and BMW. Okay, all the manufacturers, everybody start coming with different types of EV, Jaguar, Volvo, right there. Somebody will ask, but Toyota, we are not seeing your EVs. Toyota is there. Toyota is there. Okay, we have Beyond Zero or the BZ series. We have the BZ series, and we have some Lexus, and 2026, just tomorrow, maybe. Tomorrow is 2026. Okay, so for some few weeks to go, we'll enter 2026, and Toyota promised EV Corolla. Can you imagine? Corolla is one of the best selling cars in the world. And when we come with EV Corolla, you will see that yes, we are there. Okay, so we have some EVs there, even though Toyota's main push, even as today, is plug-in hybrid. Okay, so somewhere this 2025, when I checked yesterday, just yesterday, by 2024, BYD produces about 1.7 million EV vehicles. Tesla have about 1.79 million EV vehicles. VW, Geely Auto from China. We have the Koreans there. We have General Motors there. All the manufacturers start coming up with EVs, and they have a lot. The list is, that is Stellantis, and they have 281,000. Sorry, Mercedes-Benz. Okay, Mercedes-Benz, 210,000. Okay, and that is the list. 210,000 vehicles is not small. It's not small. And that means that overflow is coming to us. And it's already here. As soon as the tax on it is reduced, as for Ghana, they are not going to take it as, trust me. It can only reduce, maybe it can only reduce. We'll all bring it in, and all of us will owe some, because it's nice driving one. I hope you are there. Okay, so the layout of the EV is very simple. Few components, no complication. Okay, it is very simple. Very soon, mechanics will have to be electricians. If not, the only work you can be doing is to change brake pad. And do you know we have electronic brake, magnetic brake, that doesn't use brake pad. So, if you are still yesterday mechanic, then you are out of system. Okay. So we have the component layout, the transaxle, the motor, inverter, the battery. Okay. Then the combination meter, where you see the power, the amount of power that really tells you the car is ready to go, the power mode, amount of energy you have left, various vehicles with various design anyway. I hope you get it. Okay, so you'll be able to tell how much power you have left, okay, to cover a distance. And the system is able to tell you even how far the power left can go. We get it? How far it can go. Okay. We have the main components being the motor, the traction motor, the motor that drives the vehicle is the main component. It's inside the gearbox or the transmission. Do you get it? It's inside the transmission. Then we have the power inverter. They are AC motors. They are not DC motors. So you have an inverter between the battery pack and the motor to convert or invert DC to AC. Okay. Then we have the power control unit. Then the battery, auxiliary battery, also is there. You have the charger. Okay. So on the vehicle, we have an inverter that will change AC to DC. That is if you are using level 1, level 2 chargers. Okay, so you plug to your level 1 plug, or let me say you plug to the wall. Okay, and the conversion takes place on the car. Okay, then we have public chargers. I understand we have one here. Okay, we have few of them scattered in Accra, where I am at the Lempe area there. We have one there, and that is Drive EV. It's for Drive EV, I think so. Okay, and we have few of them scattered. However, if I move out from Accra, so I can take my EV to Pando, I will have to carry it on my head back. Okay, so we have the public chargers where the conversion takes place on the charger. Okay, the conversion from AC to DC takes place here and then into the car. Okay, we have the DC-DC converter to take care of the auxiliary power. So this is one of the DZ series, a series of Toyota. Okay, so this is DZ4. Okay, so we have the power converter here, and it's sitting on the gearbox where the motor is. The motors are inside the transmission. Like I said, it produces a lot of heat. Okay. Next time I'll come with my small mic here. Thank you. Okay, the heat is produced, and so we need cooling system. We need cooling system for the inverter. We need cooling system for the motor. We need cooling system for the battery. Okay, so we have cooling system which have to be checked periodically. Okay, making sure the water level is not that, because they can experience overheating. So overheating can still happen on EV vehicles. Are we there?
Yeah.
Okay. Then we have also cabin heating water. Cabin heating water. You see, in air conditioning, 5 minutes I agree. In air conditioning, you have the cold side and the hot side. Okay. And we know what produces the hot or the heat. Okay. We have another small radiator there we call a heat converter. Okay. So when you change your dial from the cold to the hot side, that is if you find yourself in somewhere new. Okay, then you need the heat side. Okay. We have the components that I mentioned about earlier and their description and what they do. Okay, so we have the type of chargers. We have the AC charger and the DC charger. So the AC chargers are in two kinds, level 1 and level 2. Okay. Then we have the charge control. Doctor will be talking about chargers a lot, so let me go away from that. Another good thing about EV vehicles, what the manufacturers are developing and which Toyota has already have, is vehicle to home. Okay, so if your car have enough power and you are home and there is light off, you can use your car to power the house. Yes. All you need is, sorry, this is AC charger. I have not get to the listing yet. So we have AC charger, we have DC charger. Okay, so, and then we have the vehicle to home chargers. Okay, so you can charge from the house. However, the car can also power the house if there is light off. Okay, if there is light off. That is one advantage. Then we have the solar charger. Okay, this one will be good because we have lots of sun in this country. So as you are driving and the sun is scorching, okay, it's an advantage for you now to charge your vehicle. So we have that type over there. Okay. One disadvantage we have now, which I know that the ISO or International Standard Organization will soon take care of, is different types of chargers for different destinations. Okay, the charging block. Okay, in Japan they have this standard. Chinese have this standard. Americans have this standard. Europeans have. So the blocks to the vehicle are different standards, which I know ISO will take care of now. Like he asked earlier on, distance to cover with amount of power you have is the worry for everyone who have EV vehicles, okay, who have EV vehicles. They can give you as much as 400 kilometers with about 70 kilowatt per hour, okay. And that is, the motor have a power range of 160 kilowatts. The power range of the motor 160 kilowatts, a battery capacity of 71 kilowatt per hour can cover a distance of about 417 kilometers. Okay. If it is draining, you have your information on the combination meter. Things that consumes energy is the same as IC vehicles. If you overload the car, okay, you will consume more energy. Okay, overloading will consume more energy. The weight of the vehicle will also take energy. the shape of the vehicle, the condition of the tires. Okay, you know, one tire I don't like much is BF Goodrich. It's a very good, a very strong tire. It lasts very long, but you know it consumes fuel, and it makes a lot of noise. Okay, so that is the condition of the tire will consume energy. Okay, and other aftermarket gadgets you put. This is electricity. So if you go and put Hoover in your boot to blast the community, you consume energy. Okay, you consume energy. So advantages: almost zero emission, quiet and simple. Okay. And
They will ask questions, then we will answer later.
okay.
Toyota presents Beyond Zero.
Yes, I see them. Okay.
So it's time for snacks, and we will combine the snacks with show and tell. So there are EVs down there. We also finish the snacks and then we'll be taking you in batches to go and experience. If you have an experience at EV before, no problem. For those who haven't, we'll take you down there. So we'll combine the snacks with show and tell, and we'll be back to answer questions and continue. I can see you at my end, so let's start the snacks now. Thank you.
Okay.
Please, let's clap for you.
Come, please come.
So after snacks, I take questions.
Okay. I just can't connect. Yeah. Oh, you look like one policeman, baby. But later,
your information. After this, the forming monument to have
First quarter.
So the only thing is everybody in whatever yeah, for instance, if you take a code, the motor is going to be like this man I'm talking about the motor's capacity, one kilowatt. Capacity.
Hold on. Let's check number. I can't remember.
The interview. 400. coach that is carrying people from here to Tamale, like a luggage, like STC does.
Yeah.
Okay, from here to Tamale. Okay, so that is going to require power train, power of say 10,000. Sorry, 1,000. Because Tesla is doing 1,000 plus Coca-Cola truck. Yeah. So,
and Amazon
so if I equate that to STC buses, we need power train like 1,000. Because even some cars AC voltage. And so powertrain voltage is different from the powertrain voltage required to propel the vehicle. And that is what drives depend on the someone can have a small battery, but serious capacitors boost that. So that is different.
Oh yes, yes. You need an MOU. How are you? So we need to explain it. It's not easy. It's too bad.
So then, yeah, and another thing, the nature of our cars.
The nature of our roads, suspension, so whatever IC vehicles suffer, the same for
I knew if I don't invite you, you will be angry.
Oh yeah.
That's right.
I think we met. So ground clearance with our ramps.
You see, and I think that the small hits cause
It can cause a lot of
Netherlands.
a small heat can cause a lot of damage because the circuits are very close. You see the way road go on and then you get to some ramp and you scratch. But however, they are giving you they are not exposed like that. But my problem is you drive and don't watch well when something so good students.
Let's say for example, you know on our roads on a highway, someone is carrying goods, unfortunately, finding the wrong. In your speed, you know, okay, that's how.
Yeah, it does happen. It's run under that car.
Then it causes. So I was thinking about it, and no, I've seen that some of them what they use without considering
a lot of
so that
but you know, these days before manufacturing send us destination, I don't know.
But with the EV, I'm not sure.
I know of Toyota. Before we manufacture consider some. We consider grandparents, we consider all those. So if that kind of study can be conducted for your people being cars, but the parties in already proving to us that I mean,
Sorry, the Metro Max one.
So for city
everything and still had maybe the 200 that was used for the fuel and maybe 200 more, this time around they will come back and they will only have the 200 cedis that was used for the fuel. And meaning they are incurring the cost of paying charges to the app company, and then maintenance costs become another issue.
So they were not making profits?
They were in between the time, people who had cars that were on lease, like we usually say work and pay, most of them couldn't honor the terms.
Oh, for ICE vehicles.
Exactly. Okay. So it becomes a bit of a challenge to use them for the right.
So the cost was the major aspect.
Exactly.
Okay.
Yes.
You drive electric vehicles?
Yes, so I've driven one since 2022 till now.
Where is the farthest place you've been to?
I've been to I want to remember the name.
From Accra, yes.
Yeah, from Accra.
Which region?
Western region.
Western region?
Yes.
You drove?
Yeah, I drove. I drove to Axim. Yeah, you're right. There's a place in Axim, it's a resort.
Okay.
I went there, and when I got there, so like Doc was saying earlier, you won't carry your car, but you will charge. So, no. When I remember, I'll tell you. So when you get to Axim, you know where the Science School is?
Yeah.
And then you go on that road, you make a left turn somewhere there, deep in the bush. Nobody around. Like one is like
Axim Beach Resort.
Not Axim. So Axim Beach Resort was ahead, yes. But you could see Axim Beach Resort from where we stand. The sea is what was dividing.
Okay.
And it's very expensive.
The place, yeah, very expensive. Very expensive. Very expensive.
So where did you charge?
So like that was what also necessitated the how do we call it? The home charger, the travel charger. That's the term. We call it travel charger. So once you have that one, any socket at all.
So you went with a travel charger?
With a travel charger.
To that resort?
Exactly.
And they allowed you to charge?
And they allowed
you to charge. Did you know they would allow you?
So well, the travel charger wasn't a difficult thing when we were using it in Accra.
Okay.
So once you get to know that, coming to use your lights to power my car, yes. I'm going to use just about, I think then it was about 25 cedis.
But the owners may not be that receptive.
Thankfully, there was prepaid. So you buy the lights, and then you can tell how much you have used from the prepaid.
Okay.
Yeah, so most of them, if I bought like 100 cedis, and then I ended up using maybe 20 cedis, they really feel that.
So it was risky?
Well, you can say it was risky, but for me, it was a normal practice.
So tell us maybe 3 or 4 good things with the electric vehicle as a driver.
Yeah, you get to save money.
After that, you tell me the bad aspect.
So you get to save money. Now, the initial cost of the car, if you compare it, you might want to say, it's expensive. Let's say Toyota Vitz currently is about 100,000. So you can buy 2 of Toyota Vitz compared to getting.
How much is your car you are driving now?
So currently in Ghana, some are selling it for 31,000. Some are doing 260.
Is it new use?
No used. We only do new cars.
230,000.
230,000. And then some other places. Now in Ghana, there are other places that are selling. So the new ones, they are selling between 200 and 260. But at Arijano, we have subsidized prices. Yes. You can even get a better deal.
So cost is the major driver. Cost of operation.
Cost of operation.
As in using electricity instead of fuel. It's a major driver.
Yes.
What other?
And then in terms of maintenance, also comes with a huge cost. If you compare the normal ICE cars and you compare the electric ones, the design, you realize that the ICE car have certain components based on the nature of our roads that you change very often. So like the link bar, where you may change bearings, suspension, you may change all those things that you change.
But EVs also have suspension.
So the EV suspensions, the first time I changed my suspension was after 2.5 years. Yes. And even for you who probably would use it on your normal activities, you may not change it maybe for 10 years. But I use it every day. Imagine taking this car to
Kumasi.
Yeah, I come to Kumasi all the time. I personally live in Nkoko. So my car goes to Nkoko every weekend and come back for the past 3 years. And you know the nature of that road. So my car,
now tell us the bad thing.
So for the bad things, I would say that anybody who is using it for the first time will have battery anxiety. So if you are going to assume like I did, range anxiety, some also call it that way. Now, for the first time you are going, you might think, hey, never call, that kind of thing. And then you get there, you really are not sure whether you are getting a place to top up or not. That will, for people who have BP.
But this guy is brave.
Yes. And then also, in the event where the unexpected happens, so let me give you this one for free. If you're driving an EV car and your battery drains, let's say to about 10%, or ideally you're not supposed to go beyond 10%, then you decide to charge. But let's say under the circumstance, you don't have any place to charge, but you have to cover, let's say, about 60 kilometers before you get to where you are going. And you're only left with about 30 kilometers. Keep driving, don't stop. And under no circumstance must you turn your ignition off. Don't take it off. Now, the disadvantage of that is that you will get to where you are going. So if you don't stop and you drive, you will come. Your car will not stop. So stop only when you are ready to plug in a charge. Okay, the disadvantage is that after a month or two, you may have to change your auxiliary battery. That's a disadvantage. So if you have done that for the first time, don't do it again when you have not changed your
auxiliary battery. He's talking about the 12 volts.
The 12 volts, yes. Yes. If you do it again, you may be stuck on the road. So that one is
There's a strategy.
Yes.
Because the whole thing is controlled by the software.
Exactly.
We found how to get it.
And then also, when the unexpected happens and you have the travel charger, then it's an advantage. You may plug in anywhere. But if you don't have it, then you may tow the car. But under the circumstance where you may have to tow the car.
Have you towed your car before?
Yes, I have. You're a witness to it.
But they don't know.
So under the circumstance, you may have to tow the car. Now, this is also free Apple. Now, you realize when Doc was saying what he did earlier, he was telling you that don't tow the car, with all the other things. So this is free. When you know that, let's say you have to do like 100 kilometers, but you're only left with 10%, and you may have to keep going, right? Now, at that point, stop. Don't turn the ignition off. Now, find the towing car. The towing car, this time around, you're not carrying your car. Your ignition is on, and the towing car is driving, and you're also driving behind the towing car, and will charge your car. Exactly. It will regenerate power for your car, and you'll be shocked. You will see your power running up. That is. But when it happens, the only option that will be left for you, if you don't have a travel charger, is to tow the car.
Yes. Okay. I'll come back to you. Can you say anything that he hasn't mentioned?
Well, my name is George, popularly known as Electric George. So I also consult for Ijanu as a business consultant. And I've also driven my EV for over a year and a half. So I researched into EVs. Why I decided to go into EV was one advice that I saw from a video. He's an EV technician. He has a shop. He actually converts ICE cars to electric cars in London.
In Ghana.
In London. Yes. So there was one thing he told me. If the person advising you does not drive an EV, don't listen. That was it. That's what changed my mind. So I didn't even want to go in for a hybrid or a plug-in hybrid or even an extended range. And even the Bible advises us, you are either hot or cold. So you are either EV or ICE, and not even hybrid. But of course, if you are the type that does long range, like maybe Ghana police, they might not have the time to chase all the people around. They may go in for a plug-in hybrid, which will save their daily route cost on fuel. But when they have to do long distances, say if they have to take me to Kumasi on a convoy, right, then they can switch on their engines. So the disadvantage, I'm still looking for one. The only disadvantage I'll say is not from the car, but it's from the system that we have currently, that we do not have a lot of charging stations, which we know that in the coming years, people will start looking into that. So let's say if Ghana Police decides that we want to invest in charging stations, they can do that. Talk to ECG, they get their charger, and it goes on.
Your company also is a charging station company?
Yeah, so they can actually come to Ijanu. They can come to Ijanu. Like Ijanu is having that talks with KNUST to put one of our chargers there.
We're almost there.
Right.
We are not there.
Ghana Police can decide that, okay, we want to make some extra cash. We have big compounds. We want to leverage on your solar systems, and people to come and charge, but maybe not at the conventional rate, but a little reduced rate. You'll be surprised how much you'll be making from people who may decide to switch.
So you don't have any bad thing to say about it?
I'm here too.
It's yet to find one.
What about speed?
Speed. My brother, how did you feel?
No, I mean, he just drove it here. You are going to Kumasi. Are you
Okay,
able to
so
drive
my
at the
first
speed
time to
you want?
Kumasi, I drove normal. I wasn't afraid of a risk taker. I went with my wife.
Some of us are not.
And my car runs 300 kilometers, so I knew that there's no way I won't get to Kumasi. But when I got to KNUST, I had 10%. So I was able to get to somewhere at Jesu, then plug in and charge. I waited for, where I charged, they had a level 2 charger. So I waited for about 4 hours because of my car. And I came back to Accra. And my question is, how much will it cost you today to fill your tank and go to Kumasi and back?
Well, how much did it cost you?
60 Ghana cedis.
Is it to Kumasi or Kumasi and back?
To Kumasi.
60 cedis.
So in and out,
I
you have to
believe
spend
it
120.
Just think about it.
So that is why Uber and Django drivers will like this car.
So there's a hand.
Yeah, so we'll come to that.
Oh,
Is there anything else?
Let me say something on the speed.
Yes.
So with the speed, you realize that if you are somebody who likes speeding, you know, once you get an electric car, the car will advise you.
Yeah, because it drains the.
Yeah, so the car will advise you. So if you like to do like 140, you know, on a kind of route, and without thinking that there's ties in the go and you keep doing it. Now, at some time after you have used the electric car for some time, the car now will advise you on how to speed and all of that. On that side, you are covered. Yes, safety, yes.
Have you or any of your colleagues been involved in an accident?
Yeah, we've encountered 2 accidents.
Okay, what was it? Was it a different experience?
Yeah, different experiences.
Tell us the
So one, I think that he probably was maybe tired, and then he drove into a parked car. It wasn't really parked. Yeah, it was almost like, you see, when you are in the night at 37, where the hospital is, there was this stop point where they just offload people and then they will continue. So this particular driver was stopped there, and he was almost there, but he's in the.
Okay. Were they able to fix it? Were you?
Yeah, we fixed it. The car is currently running.
Okay. One last question.
We got all the parts
before we move to audience, and then we come to maintenance.
Okay.
Would you advise that EV drivers should have some form of training before taking up?
So it's a program we run at Ijano. So before we hand over the car to you, we orient you on the car.
It is required.
It is required.
You advise DVLA to do that, right?
Well, yes, but given our system, DVLA can mandate whoever that is selling the car to do it.
So you think we should have a different license regime? Electric cars, that's my question.
For license regime, let's assume that you are a driver, he drives, and then he was trained by the old car system, so he drives and then he's time for EV. I saw one person drive one of the, I think it was you. Oh, you rather. So perhaps he may not have been coached on, like the licensing thing, but based on the few or the knowledge he got there, he's able to drive. So that way, I would rather have it to be an orientation prior to acquiring the car.
That's what they do in driver license training.
No, the driver license is a pure training, a practical one.
If you look at the theory, they teach maintenance. They teach maintenance there.
Oh, yes. Yes, but...
So EV maintenance.
Well, so maybe they can add up to what they have and they are doing.
Let me just
Okay, let's come to questions.
Just a little one to add it to. I wouldn't say most of our drivers and the taxi and the Uber drivers, the formal education is a big challenge. So I would strongly recommend the training.
The training.
Because you'd be surprised that someone will pick somebody's car and then you wouldn't know how to operate, but you force yourself to do something. Yes. So the formal education is very, very important, the training. They have to.
Okay, so these are coming from the experts.
Yes, so DVLA needs
I think
their hands. So
I think from next year going from the DVLA, they are going to register the car based upon the nature of the
nature of the car. They've even started though. I think they sampled
some. They have the sample of our
Okay, based on the nature of the car.
Yes, but you see, being a driver, you can drive. Those who even move to the bat, if you are going to register the car as a driver, I think that will be an indication. That one is from them. Okay, and then that's okay.
Someone. John wanted to say something. Okay.
There's someone at the back.
It's answered. The question is answered.
And the question is answered.
Okay. She had a hand up.
I have a question.
Okay, boss.
Okay, so the first support you were given, that when you drive and you get to, let's say, your energy level is about 10%,
yes,
you advise that you keep going. But it may not be the case because on the road, anything is possible. The police could stop you. There will be something happening ahead, and your battery may run down. So that's a poor.
So let me chip in this. When I said you don't stop, I don't mean you can't stop. What I meant to say, you don't turn off your ignition. So you may have 10%, right? And you're going to a brief from Accra. Okay. And there's huge traffic from here. That traffic don't even impact on your battery that much. It is very minimal. Now, in such circumstances too, I don't expect that you put your AC on.
We'll handle that tomorrow. Use care.
So to be clear,
yes.
So you don't switch off, you don't turn off. If you don't turn off and you delay even like 1 hour,
you are safe.
You are still safe.
You are safe. Yes. You are safe.
Hello. A typical experience. I went to Singapore. When I was coming back on the motorway, and I got to Manette Junction at 0%. So what would I do? My car was still running. So I drove from Manette Junction to ANC Mall, and I charged. If compare it, I see you. If you see the red on the motorway, what do you think will happen?
So you know, the 0% is for your viewing.
Yes.
But the battery itself is not drained to 0%.
Yes. Okay.
The
so
programming sometimes they don't allow you to drain it beyond 20%.
20%. Yes.
So what he's seeing is 0. But some cars will they will cut it off.
Like the Tesla will cut it.
Yeah.
So what he said, when you take the dashboard of the car, the one that shows you the odometer and the other one, it has a volt on the car. So mostly cars that you can see the volt. And then there are other ones, it tells you the kilometers also. So both will be there. One on the left, the volt is mostly on the left and then the kilometers on the right. Now the volts, when you charge your car to 100%, depending on your battery capacity, let's say if you are driving the one out there, it will give you up to 308 volts. Now, by the time you have drained your battery from 100% to let's say about 10%, you may have 252 left. Okay, so at that point, you realize that your kilometers is about 10%. But remember the volts, when you started, it was 300 and something kilometers. So you still have more volt, like what you were saying, they don't allow you to see. So the volt is there, and me, my first time experiencing that, or my first time I took that risk, I did the calculation based on the volt. Yes, and I was able to conquer it.
Don't be doing that.
Oh yes.
Anyway, Morgan.
I want to. Okay. Like they are saying, you can go to zero and drive. However, see, some people walk on water. Peter walked on water. It doesn't mean you should go and walk on water. The thing is, it's like he said, it's more or less a fail-safe system where there's a backup power which you can use for a few kilometers to drive to safety. Because if you are driving and you see 0%, and then you stop, you are like on the road like in Koko, the dual carriage, and the car is supposed to stop. It won't be helpful. So then it's a fail-safe, so that when you see zero, go to a safe place where you can park. We don't encourage drivers to drive below 20%. Usually 20. Ideally, you should keep the charge between 20 and 80, because that's a stable range for lithium-ion batteries. Going that low is not safe for the cells. The batteries have cells that are arranged in them. So if you have to go that way, you're using your car, some people are using it for 5 to 10 years. Within the next 3 to 4 years, you'll be changing your
battery will degrade. You have to change it.
So yes, it is. What you are saying is they've experienced situations like this. What you are saying is that you are giving your allowance. Just be safe about it and play safe. Thank you.
Thank you.
So, yes. Okay, thank you. I want to know about the weight of the vehicles.
Yeah.
Sorry. Yes, I want to know about the weight of the vehicles. If you look at IC vehicles, because of the engines and other parts, I think they have more weight than that of EV vehicles. You were seeing from outside. I was trying to see whether I could see something like an engine, but I did not see that. I was only seeing batteries and some cables and all that. So I want to know whether the engines are equal to that of IC vehicles.
EVs are heavier than equivalent IC EVs because of the battery. But the battery is designed to integrate into the car, to balance it. So the whole under is flooded with battery nicely for stability, but it's very heavy.
If you happen to have the battery system that can actually remove one after the other, you can't lift it around.
It's very heavy because of the energy. Oh, Morgan.
Auntie has not asked a question.
Wait. Morgan, finish it. Or Auntie, okay, give it to Auntie.
Thank you. I want to know what's the maximum kilometer per hour?
Oh, the speed.
Yes, the speed.
Oh.
Then the second question is about availability of parts. The availability of parts. The third one has to do with mechanics. Because we realize that in our current system, we see, excuse me to say, forgive me, some illiterates who being trained to repair our vehicles. If you take the dealerships out, but we have other people who also maintain our vehicles. looking at the status and the things the specifications and the things we talk about, we realize that we need people who are intellectuals to be able to train and then manage these vehicles for us. So what's the way forward?
In terms of mechanic, Philip, for instance, is a fully blown tech product that is into this field. Okay, so the field, and Professor, this morning we were talking about something that is being done. There are a lot of people that they are being trained. Last year they did a batch that are already in the system. Okay, so in terms of that, you are rest assured, you are there.
I'm sorry.
So to address the speed issue, electric vehicles, the very fast ones, can go as fast as, they can go as fast as the Bugatti.
Yes.
They can go as fast as the Bugatti, but they are built for that. The ones we see on the roads, these ones, they usually have a limitation. Usually what happens is when you see them going for a race, electric vehicles are very fast on the takeoff.
Very
so
fast.
Those who drove, as you were learning or adapting to the pedal, you realize that it's very impulsive. And so on the takeoff they are fast, but when they have a smaller top speed range. So you realize that on a very long stretch, they reach their maximum speed. 120 up to, and 200, 220 is okay for a family electric vehicle. So when they reach that range, they cease to go faster. But when they are racing with ICE vehicles, later they come to pass them. But then I think in the city, and even on the highway, on our highways, how fast could you go is the question. But you can handle it. So this one, the small ones. Yes, no, but then these small ones. The point is, their range is between 120 to 220. And then the race cars, those that are designed for racing, go very, very fast. That's just that one thing you have to understand is the faster you go, it drains the battery. The more you step on it, the more you give the click down in the engine. We see if you are engine, the engine is making that sweet noise. You consume more battery, and so you get less range when you are using the EV. The parts availability, let me finish with it.
Let me do my job. So in terms of the parts, if you want to buy, that's why you need to get it from us. Done. So once you are buying it from us, you are rest assured you have the parts.
Genuine parts.
Yes, genuine parts.
So,
however, when you take a product like Toyota, Hyundai, or Hyundai, whichever one. So when you take those products that are already in the market, most of the parts are similar. And if you take it there, like you buy from Toyota, BZ3, and then you take it to Toyota and they take the part out, they'll be able to tell you that, oh, this one will match with so and so. But with EV, ensure that you are buying the manufacturer's part. They will keep the part.
The specs.
On the part. So what's the warranty? Warranty on that?
Or if you are buying it from, like, Kijano, yes, we'll give you warranty.
What's the warranty?
What's the warranty?
So currently what we give is 6 months.
6 months?
Yes.
Is it new, brand new?
So I'm coming for, you see, most of our cars on the road are doing a daily work. So they wear off very quick. Yes, but the warranty we even give to the cars differs from what they are using it for.
Okay, so 6 months?
No, for the ride-hailing ones.
For the ride-hailing.
Because some of them now, they are rough drivers.
Yeah, like your cars, you abuse the car.
The parts, not all the parts are ready. The thing is, some are ready available, some are not. Suspension, depending on the car. You see, our car, the blue car that you drove, it shares the chassis with a Renault Kwid. And so when things like your lower arm, your brakes, the shocks, when those things go bad, you know that if you go to Renault, you can get some. Some of you go to Abuso kind of easy, you can get some parts, but with our vehicles, or most of the cars, electric vehicles that are coming, they are Chinese cars. And so you don't easily get the parts. They'll ask you where a car being. You can't, because if you say Dongfeng or if you say Jili, they can't relate. So we start out like what I tell them, oh, Renault Kwid. Oh, okay. But even there, some of the parts are, you don't easily get them. Now, with the high voltage components, that one is trouble, slightly, because there's no company, well, okay, there's a Chinese company that sells some of the parts, but then all the parts you have to import is the thing. Yesterday, I diagnosed one car and his AC compressor has gone bad. We can't help you today or tomorrow. You have to import. So those high voltage parts, yes, you have to import. That's why some of us, if we want to go into that space, we are in that space to get some of the to get some in stock so that we come. But you also have to notice that VW is different from Benz. Toyota is different from Nissan. So even if I have parts in stock, if you come that you want part of the trade, you likely to get.
They should hear the truth.
So the case is that parts, most of them have to be imported. So with the mechanics, like Dr. Ito stated earlier, there are certificate training programs that have been had. I also know personally one or two people who have gone to China and have trained and have come. So for sure, you can get them, but they are not as many as you find at Abusoka.
Prof, let me say this. Having used it for 3 years, all the mechanic works on EV cars, okay, they are as the ICE cars. It's not different. The only thing is that we encourage or we inform the mechanics that are currently working on them to use appropriate tools so that they don't have to hit, the head of my car, bang, 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 like the way they do to the other cars. That's the difference. But if you take those cars and you put them there and you put the ICE cars there, they'll be able to work on them, and which I have done it like several times.
Okay, Morgan, finally.
Thank you. Please, I want to ask whether all EV cars, their bonnet can be open. Because I saw this Mercedes-Benz that they brought in, and then they cannot trace where they can open the bonnet. So we have to send from the manufacturer that they should show us. What? Yes.
But if they had bought it from a company, they would have showed them. Person to be imported it himself.
What we saw is that
Manual.
we can't open it.
No, they can't read the manual.
Yeah.
The person imported it
We
himself.
can't open it. They said you shouldn't touch it. You should leave it like that. Because I saw your own.
No, because if there is a problem, the mechanic has to work on it. There is a way to open it. I'm sure. What do you have to say?
No, to answer the question. Okay. So it depends on some of the cars are done electronically. Tesla, for instance. Tesla, you have to do it from via the screen. But then there are manual overrides that you can use. Sometimes you have to go underneath the car before you can access.
Yes, because there is a high voltage component. You saw the orange cables.
Yeah.
Those are high voltage cables. It doesn't mean if you touch it, it's electric. It means that if the wire is exposed and you touch it, you die. But it is insulated. But just for you to know there's a potential for you to commit suicide. It doesn't mean if you touch it, but no. It doesn't. Okay, we finished it.
Second question is, this one is here for my voice.
We'll talk about motorcycles tomorrow. Safety. Don't worry. We'll cover it tomorrow. All the challenges, we'll cover it. So if it's motorcycle,
I had one of the drivers that he moved from Accra to Kumasi. And then he used 60 cedis. In and out is 120.
yes, it's true.
And then in Ghana, one thing I realized is we have market town streets. Because now that they want to bring the EV cars, they will be preaching very sweet words to us.
Too good to be true.
I'm coming. So that we'll buy it. But after you buy then comes another different story altogether.
Okay.
So they should tell us the truth earlier.
Oh, but they are telling you what they are experiencing.
Prof, let me help him. I think that from here, do a survey. People who are using EV cars, randomly ask them how much they are using to charge their car in the house. And then commercial rates also are there, like Silver Star, they are doing commercial. And then other places, there we have about 15 points now in Accra. So you can ask those commercial rates and ask those who are doing it in the house.
I think
so you don't need to take it from
his fear is for the future.
Oh,
yeah, because
so in the future, that is why you need.
It may be quality.
Yes, so in the future, let's
so that people are buying it. Then you bring in the inferior ones.
Inferior says a
for example, type Benz, if you're strong, compare and the Benz.
I don't know. It was the earlier times that they were bringing in inferior EVs, but now it's very strict.
Even now, the ones that are coming later are better than the ones that came earlier.
Yeah. So no fear.
Please let me answer his question. So just to confirm.
So you shorten your answer.
Just to confirm the price that we are telling you the truth. So on my app that I use to charge my car, I did a 21.4 kilowatts. And even over here, they said they are charging 5 cedis per kilowatt. Please multiply it by 5.
5 cedis per kilowatt hour.
1 kilowatt hour.
So multiply the 21.4 kilowatts by 5. What do you get? 105. That's what you
commercial rate. That's for commercial rate.
It's clear. How many hours? Okay, let the Abai answer.
This one will give you between 2 to 3 hours, depending on also on the size of your battery. Yeah.
So this was a fast charge.
You can show it to him later.
But this one gives you 30 minutes. What is you talking about?
Just 30 minutes. 100 cedis.
Okay, your question?
Yeah, my brother was struggling to know one of the disadvantages, but I want to ask, in case of collision, and this is electric, the possibility of catching fire. And then the second one is the body material. It's made up of metal, fiber, plastics.
So in terms of the body parts and the materials, Philip will be the best person to speak on that. But in terms of head-on collision, we've had, I think he mentioned if we've had accidents on them.
Yes.
We've had 3 of them. And all of them, none of them caught fire. And I'm speaking in terms of new cars. The new EVs, that's why we are telling you, don't buy home-use electric cars. Buy the brand new ones from Ijan. So we've had 3 of them, and all of them, they didn't catch fire. We prepared them back on the road, and they are functioning properly. Yeah. So after the work we do on them, you looked at it and you look like it's even better than the one.
We'll talk about fires tomorrow.
Auntie had a
fires.
Oh, sorry, the body part.
There is a bad aspect and there's a good aspect.
Yeah, the material.
There's a combination of materials. There are also alloys. So there's a metal, there's plastics. They are also they can catch fire. They can catch fire, but there's something like a pyro fuse where it's supposed to disconnect to protect the system, the electric system.
Please,
Now, there's a
this has
question.
been out.
Yes. Let's finish it. I mean, he will finish this place, then we'll go ahead.
Yeah. Hello. Okay, so thank you very much for sharing your experience.
Oh, I know.
The Energy Commission.
Yes. So, in Ghana we did, somebody said in Ghana we did. So, with electric vehicles, you used yours for 3 years. What are some of the things that are likely to be stolen by thieves?
Thieves?
Yes, that is
Okay.
the first one.
Okay.
And then I know there are a number of interlocks. Okay, so for instance, in the event of a collision and all that, there will be an interlock to make sure that the batteries do not charge, they disconnect and all that. So, can you take me through some of the things that you are likely to change often?
Often, okay.
Yes, with an IC vehicle, Acha 5,000 kilometers, best on your mechanic, and go so many things and all that. So, if you can take us through some of these things, I'll be very happy.
All right, quick one. For your information, Energy Commission has a level 3 charger. So when you are buying one, remember they have one too.
It's not open to the public.
But if you are in need and you go, they will help you.
Really?
Oh yes, they will help you.
We shouldn't come there.
Come for a meeting. Come for a meeting. Come and see.
Please, can you answer the changes? The maintenance.
So as for the maintenance, like he said earlier, most of the parts that you change it has to do with suspension components because he has driven for 2 to 3 years. He has done like 200,000 kilometers. Yes.
Yeah, over 200.
He has done the most.
Wow.
Yes. And so far, he hasn't had to change a high voltage component.
No.
On our cars, the first high voltage component we've had to change is the AC compressor issue I'm talking about. And so basically, parts that you change are common with
suspension,
the ICE vehicles, except the engine.
So it's cheaper.
Yes.
Cheaper,
So,
yes.
Godwin will be talking about maintenance.
Oh, the thieves, yes. So you see, normally in Accra, what has been happening these days is they steal your mirror, your mirror, and then the auxiliary battery. But fortunately for you, most of the 12-volt batteries on the electric cars, they are in a way that they cannot be removed easily. Yeah, they have lockers on them, most of them. Even the most common one, which is this one, has some sort of, you need some screws before you can take them
So they've not stolen you or anything?
Nothing, no. I've left it at the office several times when those days when our solar was out. Yeah, I will charge on the slow charge.
People have not figured it out.
So you see, it happens when the car is common. When the car is common and they don't have their parts, then they start stealing. Expect the usual things that they've been stealing, that it can be done also.
Well, I wanted to find out, are you open for training? For instance, I want to come and learn how, because this is just a brief thing that you introduced us to. Some of us is the first time, if you do now, and how long does it take, and how affordable is it? And do you run weekends, something I want to find out. Then the second one has to do with, we are talking about zero emission, but environmentally, how do you dispose of the batteries? Because you are struggling with e-waste.
Yes, Prof will deal with that. And then the training also, Prof, there are other ones that have been run over time. And, yeah, some of us have become.
So, we need, okay. Hey, now you are an expert.
No, I want to compliment.
Okay, give it to me. 1 minute. He knows everything. Yes.
Yeah, okay. People are, like the question our brother just asked you, are you sure of what you are saying about the range?
Yeah. Or the money and the range in terms of what you
have. But I'm running a shuttle. And when I charge,
brother, please, are you listening?
35 kilowatt hour
the maximum I pay, depending on whether off peak or on peak. Hence I pay 60 cedis.
For 35 kilowatt hour, 60 cedis.
Yeah, and that means we trade to about 5%. So we are charging 95%. And we use that to cover 300 kilometers. We go 6 trips from Tema to Choko. 6 trips. And when I have a whole data, which is about 60 kilometers, okay? And as compared to my ICE vehicle, every 1.5 days, I have to buy 2,000 cedis of fuel.
Boss, please do the math. 2,000 minus.
Because he has a mixed fleet.
Yes.
A mixed fleet.
2,000 minus 60. Boss, how much are we getting? Exactly.
Besides that, if you have trained the drivers very well, the characteristics of the bus is different from the
small ones here.
The saloon cars, some of them, the way you press hard, from 0 to 100 kilometers per hour is within 3.5 seconds, right?
Yeah. Yes.
But it's not safe for buses. Yeah. So buses, the opposite. When you press hard, it will rather decelerate.
It's a safety measure.
One good thing about EV, they don't fear traffic. Neither do they fear the Eburi Mountain.
No.
They climb.
Talk.
We charge from Kolebu to Koforidua, that's 60 or even less. We have 100%. Goes to Koforidua and comes back with some percentage, and then we top up. Another good thing about the EV is the regenerative braking system. If you have trained very well, your brake pad can last for 5 years before you change it. And if you are very, very careful, please, when the first presentation was made, they say they need what? Coolant. In your ICE vehicle, the coolant, you've thrown it away and you've replaced it with what? Water. Never, ever dare with what? EV. Let it be solely what? Coolant. And the only thing you do is to blow inside. Never put water. Are you with me? And don't be surprised that its management about power consumption is something that is mind-blowing. It's not DC motor. It's pure 3-phase AC motor. All right? And it's been driven by what? An inverter, a frequency drive. So the speed, don't try. Don't try. And the last thing to say is the air conditioning in there, very, very good. I have my oldest bus, 2020.
So date 5 years.
And it's still going. Somebody is chasing me to sell it. And it's a 17-seater bus. Very comfortable. The suspension, once in a while, because of the bad nature of our roads, okay, we have to change suspension. And people enjoy it because when it's going and the windows are closed, it's like you are sitting in a plane. You don't hear anything. To the extent that they even start asking us, but why is that you don't make noise? Is it not dangerous? Okay, I want to tell you, having EV is the best. I mean, pure EV is the best. It's the best because, like my sister was trying to ask, you are maybe a worker where you charge maybe once in a while, once in a week, you charge. And when you are charging, in the night, the car, you sleep. The car will not sleep. You can charge it. And the AC charger will take you through. Before you wake up, it is there.
BMS does the work for you.
All right. And we are promoting green. Very soon you go on retirement. Plant solar. And when you plant solar, your solar in the night, you charge your vehicle for it. I have it, and it's working perfectly. Okay, so it's saving me a lot. I'll tell you more tomorrow.
Yes, yes, thank you very much. He has a fleet of buses. Because of time, we will reserve the questions, some other questions. Yes, you took our time, because experience is better than theory anyway. So thank you very much. They will be around for more questions. So please, can we clap for them, please? We want to invite Climate Compatible Group. They funded, they have a collaboration with Kenya University. They made sure you don't pay. We wanted you to pay for this session. They say you shouldn't pay. But next year, don't worry, you pay next year. So we want to appreciate them and for them to tell us what they usually do.
All right. Thank you so much, Dr. Aito. My name is Akwesi Edupoku. I'm a research fellow with the Hammond Energy Center. And I'd like to say on behalf of the Climate Compatible Growth Program, which is coordinated at the Energy Center, we are very happy that you honored our call, and we are willing to support you more. So CCG is a UK Foreign Commonwealth and Development Office funded initiative, which is currently operating in 6 countries. So we are in Ghana, Kenya, and Zambia in Africa, and we are in India, Vietnam, and Laos in Asia. So in Ghana, we operate in 5 special interest groups. I think you can see them here. So we operate in the first one, which is sustainable transport and new energy vehicles, which is leading this very workshop. We have green hydrogen, we have an inclusive net zero emission future, we have clean cooking, and finally we have the financing the energy transition special interest group. So you are welcome to join any of our special interest groups. I'm going to be around with you today. If you are interested, just talk to me and we can sign you up to join our groups. I think this workshop is both relevant and timely, especially now that we want to, I think we are in the first phase of the EV policy, where we are looking at the takeoff, right, which started last year and is going to end next year. That we envision that by 2035, Ghana would be deploying 35% of cars on our roads should be electric vehicles. And we already know that the transport sector is the largest emission sector when it comes to the energy, right? It contributes about 25%. So we want to, support the sensitization. We at CCG, we provide partnerships, we provide funding, we provide capacity building, and we have a lot of experts in our group that lead these workshops. So I'd want to thank you all for coming, especially for the Energy Commission for the leadership, our expert facilitators, and all participants and stakeholders in the AV space. I hope you enjoy the workshop. It's already been fun so far since I came in. I hope you engage more to get more insight. Thank you.
So the special interest group are international in nature. So for example, for the electric new energy vehicles group, it's an international. Energy Commission has people part. The police can join, anybody can join. And we plan our programs nationally, internationally. We work with the Germans and Americans and all that. So we can always join any of our interest group. Okay, so without wasting my time, let me invite Godwin from Toyota to give us a brief idea about maintenance. Some people ask about mileages, what to change and all. Thank you.
Right, so good afternoon, everyone. Yes, nice to be here and to be facilitating on this program. So my name is Godwin Rajib Deibe. I'm the National Technical Lead for Toyota Ghana. So one of the core jobs that I do is to provide repair support to our branches when they have challenges in fixing problems. Okay. So today we want to talk about maintenance in the context of total cost of ownership. So I think a lot has been said already, so I'll just gloss over most of the stuff. So to begin with, I want to ask, what would be your priority criteria when you want to purchase a vehicle? EV, ICE, putting everything together. What would be your number one criteria that would enable you to decide which vehicle to buy? Okay, safety. So the vehicle should be safe. Do you know what is the most safe vehicle in the world today? Safest vehicle? It's a Toyota, okay. So I think arguably the Land Cruiser 300 has a certain technology that protects the cage of the vehicle during an accident. One of the safest vehicles you can get. I'm not doing marketing, okay, just. Okay, so yes, which other? Any other suggestion?
Low consumption.
What? The year of manufacture. Okay, so assuming you have two vehicles and both of them are manufactured the same date, what would be your number one priority? Somebody said fuel consumption. Luxury, okay, so it should be luxurious, like Corolla, LE, and the rest. Okay.
Reliability.
Yes, any other?
Reliability.
What? Okay, ownership cost. Somebody said
Reliability.
reliability. Okay, so for me, availability of parts. Okay, so these are all very wonderful answers. But for me, my priority will be performance. When I say performance, acceleration, you know, like somebody mentioned that when you are driving the EV, when you are driving the EV at, let's say, 120 kilometers and you need to overtake somebody to move to 150, he says it doesn't move as fast as the IC engine. I heard something like that. Okay, so performance, when you are accelerating from one point to the other. For me, that's what makes me feel a vehicle. So that's one thing I might look at. Okay, so that's just to put what we're going to discuss in context. So we're going to talk about total cost of ownership. This happens to be one of the important criteria that usually you should consider when you want to own a vehicle. Okay, so all the ones we have said, okay, no matter how rich you are, you still will be cost sensitive when it comes to making a purchase. Okay, so as a result of that, I want to see how, when you juxtapose an EV and then an ICE engine vehicle, what is the comparison when it comes to the total cost of ownership? So we selected the Geely EX5, and then we also selected its counterpart, which is, in fact, the Geely EX5 is a crossover SUV. It's not a 4x4. Though it's an SUV, it's crossover. So we picked the Qashqai, okay, or the Corolla Cross as an equivalent to do a comparison. Okay, so these are usually in the same price range and then also performance range. And size, yes. Can I have the pointer? So while we are waiting for the slides, so we said, how do you call it, Geely EX5 is what we are looking at. Now this is a crossover SUV, meaning it's an SUV, but a proper SUV. SUV means sports utility vehicle. So a sports utility vehicle should perform as such. It should be a 4x4. It should have very good ground clearance. When it hits off-road, it should be able to perform well. But these days, we have something we call crossover, which is between the 4x4 and the saloons. And these usually look like 4x4s, but are actually 2x4. Okay, so that's why we call it a crossover. As it were. Okay, so like I said, we're looking at the Geely EX5 and then the Corolla Cross or Qashqai. So these are its ICE equivalent. So initial price, these are rough estimates. Okay, I think there was a consultant for Jano here. Okay, so these are rough estimates. So Corolla Cross Qashqai, the initial price would be around 400,000 Ghana cedis. Around, okay, initial price around that 400,000. Then for a Geely EX5, usually EVs, because of the battery, the cost of the battery. So EVs are usually a little more expensive than their ICE equivalents. okay, based on the cost of the battery. But usually, like it was said initially, most of the other specifications and all that are the same. Okay, so when you compare these two, you see at a glance that the ICE engine vehicles are are cheaper. And so if you are cost sensitive, you might want to buy the ICE engine vehicle, but is that the case in the long run? Okay, so when you look at estimated resale value, assuming you use the vehicle for 5 years, okay, and you're going to resell the vehicle to buy another one, what will be the resale value, depreciation? So we see here, because EVs usually, in Ghana now are not so popular, okay, you're not likely to have a very good resale value as you have for an ICE engine. Okay, so based on that, considering 47% depreciation for the Geely, and then 60% depreciation, so you come to 200,000 Ghana cedis, okay, retained value for the Geely, and then you have about 240,000 Ghana cedis, which means that depreciation is the highest variable for EX5 in Ghana due to newness. So it means that the ICE engine vehicle would appear to have more value, better value. Okay, so based on this, the net cost of the depreciation we see is 225,000 Ghana cedis for Geely as against Corolla Cross, which is 160,000 Ghana cedis, leaving you with a higher resale value for the ICE engine vehicle. I hope you understand. So we are moving through parameters, okay? And mostly, these things we are doing, institutions that buy vehicles are more conscious of these things than individuals, okay? And this is because most of them, like fleet owners, somebody was a fleet owner here, they normally would have to make projections to make sure they are spending right. Okay, let's move on to the next slide. Okay, so now let's look at running costs. Okay, we have Energy Commission here. So we look at running costs. When it comes to efficiency of the Geely EX5, it's 18.2 kilowatt hour for every 100 kilometer run. Okay, you can call that a consumption, the equivalent of consumption for the ICE engine vehicle. Now, when you come to the Corolla Cross, we have 6.0 liter per 100 kilometers. You can convert this also to kilometers per liter. Okay, so when you look at these two, so based on international test cycles, okay, we wouldn't really be able to decide much. But when it comes to total energy that's consumed, okay, for a period of 5 years, at this consumption rate, you are going to get 18,200 kilowatt hour for the Geely EX5. That's the total amount of energy you have consumed for 5 years. Okay. Now, when you come to the ICE engine equivalent, you would have consumed 6,000 liters of fuel. Okay. So, considering or assuming cost of electricity to be 1.5 Ghana cedis per kilowatt hour, as we have now, I think currently it's ranging between 1.6 to 1.8 or so. Okay. Yes. Okay. So 1.5 Ghana cedis per kilowatt hour for home charging, okay, off peak seasons, and then 30.5 Ghana cedis for a liter of petrol. So here, what does it bring us to? It brings us to 27,300 Ghana cedis, okay, for the amount of energy consumed, as against 81,000 Ghana cedis for the amount of energy consumed for the ICE engine. So if you are interested in running costs, which usually comes as a hidden cost, a lot of individual vehicle buyers do not look at this. Okay, sometimes they just reduce it to engine capacity. I want the engine size to be small, but you might want to pay attention to the consumption rate of the vehicle. So here we see that for running costs, the EX5 saves 53,700 Ghana cedis on energy. So you don't just go look at the price of the vehicle. Okay, consider the running cost, let's say, for a period of 5 years. Okay. Now, maintenance. When you look at maintenance also, we have routine service costs for a period of 5 years. Here again, for institutions that want to buy vehicles, sometimes they buy something we call maintenance package or service level agreements for a period of 5 years. So they pay for the vehicle and also pay for a period of service. Okay. Now, for such cases, you see that for a period of 5 years, for the Geely EX5, you are likely to spend 27,500 Ghana cedis on maintenance. Maintenance meaning service and routine maintenance. We are assuming here that the Geely is under warranty. Okay, so the vehicle you're buying is under warranty means that the battery has an 8-year warranty coverage. So if you have an issue with the battery, you don't spend on it. I think it was talked about suspension replacement. A lot of those components, once the vehicle is under warranty, you don't have to spend on it. So these are actually the things you spend on. Okay. Oh, sorry. Right. So 27,500 Ghana is for Geely, and for the Qashqai or the Corolla Cross for 5 years. Okay. Maintenance cost, you are looking at 82,678 Ghana cedis. So here again, we see that we make savings for the Geely EX5. It's cheaper maintenance cost. Okay. All right. Now, just a little information to add. I think it was mentioned earlier, when it comes to the brake pads, someone mentioned that the brake pads last longer. Okay, so information has it that it takes, I think, about 4 times savings. So if let's say the IC engine equivalent to be replaced once in a year, that's once in 20,000 kilometer run, okay, then it will take about 4 times longer period for you to replace the brake pad of an EV. And the simple reason is because for the IC engine vehicles, when the vehicle is moving, any time you slow down, the brake pad comes into operation and works. But when it comes to the EV, anytime you slow down, you have the regenerative braking. So the motor itself does the slowing down, and so the workload of slowing down is not so much on the brake pad. Okay, so you have that gain. Okay, and that explains one of the reasons why the brake pad takes a longer time. I'll give some detail on that, you get to see it. All right, so here, for total of 5 years maintenance cost estimates, you have EX5 saves 55,178 Ghana cedis on maintenance. Okay. So the question is, what's the detail of the maintenance cost of EX5 being cheaper than the ICE equivalent? So just a few, they've really been mentioned, I just gloss over them. So for the engine oil, the engine that you see of an ICE engine has about 2,000 moving parts. And once components are moving, they have to be lubricated. Okay, 2,000 moving parts. The Geely EX5 has about 20 moving parts. And so you notice that it becomes necessary to lubricate and therefore do frequent replacements of lubricants, okay, in the engine alone. Then you talk of the transmission. Okay, so in that sense, for engine oil replacement, you don't have that in the electric vehicle. Okay. Now, when it comes to gears and clutches, we also have complicated transmission or transaxle systems, which also have a lot of moving components, which would fail in the manual transmission. You even have clutch discs, which would fail, and you would replace them over time. Yes, and all that. So when it comes to the Geely EX5, it's just a simple reduction gear mechanism, which does not require so much maintenance routines. Okay, so in that sense here also, elimination of the transmission fluid changes and costly clutch transmission repairs. Okay, so here it doesn't mean that the EVs do not have transmission fluids. The issue is that for the modern EVs with the modern technology, they usually don't have the inverters separated from the motors, as we saw in some of the vehicles. So they are integrated together as one unit, one to lighten the vehicle. Okay, so you lighten the vehicle, then you spend less, electrical power. So based on that, you come to have the fact that you spend less. Okay, you come to spend less. So, so we said simple single speed reduction gear unit, which eliminates the transmission fluid. So there in the Toyota BZ series, this unit, composite unit that I'm talking about, has something like a transmission fluid replaced, but it takes a longer time as compared to the IC engine equivalent. Okay. So that is called the E-axle fluid for the Toyota BZ series. Okay. We also have an ignition system, and we talked about combustion that happens in the engine. Okay. Now when it comes to the engine, you don't have that. So you don't have to replace spark plugs, ignition coils, and all that comes with it. Now when it comes to the exhaust system also, you also have complex systems like the catalytic converter, the oxygen sensors and all that. All those things their maintenance and all that are also avoided. Okay, so all this explains why the maintenance cost of the EV is cheaper than the IC engine equivalent. Okay, so braking system regeneration versus friction, I have talked about that and explained that it takes about 4 times longer. Okay, and a little detail will show the duration for replacement of the brake pads for the IC engine as against the EV. But when it comes to the issue of brake fluid, both of them have brakes. Because of exposure to the atmosphere, the brake fluid has to be replaced. So with that, there's no advantage of the EV as against the IC engine. Fluid filters and periodic checks. So here again, when you take the engine coolant, we replace the engine coolant every 40,000 kilometers. But in a Geely EX5, we replace it. We replace every 80,000 kilometers to cool the high voltage battery and electric motor. So there's a coolant, even though it doesn't have an engine, but there's a coolant that you have to replace. The only thing is that its duration of replacement is longer than the ICE engine. Right. So when it comes to air filters also, we have the engine has an air filter, then the cabin of the vehicle also has an air filter. So the engine's air filter is eliminated. You don't have that in the EV. But when it comes to the cabin, there's AC in the EV, there's AC in the IC engine. So with that, then you have that replaced. Battery checks also. Battery usually will last from 3 to 5 years. Okay, 3 to 5 years. And if it gets faulty earlier, warranty again covers it. Okay, but so high voltage battery checks would usually be done not in the case of replacement, but in the case of cell balancing and certain maintenance procedures that will be done in the diagnostic tool. So these are not things that will require the whole battery replacement, like the case of the IC engine equivalent. Okay. So when you look at specific details now, we see here we have washer fluid. Just very quickly, washer fluid, sun plug washer, engine oil, a list of them. There are about 114 components or tasks to be conducted over a period of 5 years for an ICE engine. Okay, 140. So the washer fluid would replace 20 times for that period. The sun plug washer would replace 20 times for the period of 5 years. So when you put all that together, you have about 114 tasks for a period of 5 years. Okay, but when you take the EV, you have 32 tasks. Okay, so just in a layman's idea, you can see that dividing just 114 by 32, you could say about 1/3. Okay, you can see already that 1/3. It means maintenance-wise, it becomes more expensive because you are doing more work, more tasks in the case of the IC engine vehicle as compared to the EV. So that can even be a basis. That can even be a basis to determine that if we have 82,678 Ghana cedis, you can just do a rough estimate, divide this by 3 to give you the estimated maintenance cost, just by looking at the ratio of the maintenance tasks. Okay, putting even labor aside and all that, just looking at the parts alone, you are able to make that simple analogy. Okay, so now putting all together, so we see our total ownership cost. The Geely EX5 net depreciation cost is 225,000 Ghana cedis. The total running cost is 27,300. Total maintenance cost 27,500. Estimated 5-year total cost of ownership, putting all together, you have 279,800. Okay. Now, when you come to the Qashqai and the Corolla, you have net depreciation cost 160,000. Total running cost 81,000. Total maintenance cost 82,000. And estimated 5-year total cost of ownership, 323,678. So here you see that the EX5 is making a savings of 43,878. And that makes it cheaper than the IC engine equivalent. All right, so a very quick summary. I mentioned 400,000 Ghana cedis for the Qashqai. So you can consider that as a price range. So the price range 380,000 to 430,000. Price range for Geely EX5 more expensive because of the battery. Okay, the battery. Then you have energy cost per 100 kilometers. So you have from 12 to about 18 Ghana cedis. Okay, for every 100 kilometer that is run. Then for fuel, you have 75 Ghana cedis, 210 Ghana cedis for a 100 kilometer run. You spend that amount of money for driving 100 kilometers. Okay. So by this alone, you see significantly cheaper EX5 is making a lot of savings. I think there were talks about the fact that you drive 300 kilometers and spend only 60 Ghana cedis. So these are the real figures when you want to calculate them. Okay. So routine maintenance also we see very low because there are lesser tasks, maintenance tasks to conduct on this. The major component life is the engine and the battery. However, the battery warranty is 8 good years for every OEM manufacturer. So I don't know for Ijano, but for an OEM manufacturer for EV battery, it's 8 years. Same for Toyota. Okay. So when it comes to the engine also, even if you put warranty aside, the engine is one of the major parts of the vehicle that lasts the lifespan of the vehicle. So with that, you wouldn't really be able to see an advantage. Okay. Then road tax registration, MD today talked about the taxes at the port. So for road tax, that's the annual taxes, road renewals of roadworthiness. So for that, we see, in fact, we know that they are supposed to be lower because there are some incentives that have been promised and we are yet to see. Okay. So the resale value also you have, because EVs are not so popular, so they don't have so much of a high resale value. So in conclusion, Geely EX5 replaces routine expensive consumables, as have been mentioned, and highway mechanical systems, as have also been mentioned, with simplified electric motor that requires little more than fluid checks and diagnosis monitoring, which makes it cheaper. So for all criteria, if you put all criteria aside and you look at just costs, I think this should be justifiable or reason enough to make a purchase decision in favor of an EV. Thank you very much.
Do you have any questions for me?
Any questions?
It's clear.
Yeah. Question?
Thank you very much, sir. My name is Kelly. Concerning about your presentation, it's quite professional. I like that. And even with the experienced man here, I wish he's here. My concern about your presentation, and I can see a lot of institutions here. And this target or this presentation, I don't know how it collaborates with the technical university in Ghana, because they are the one training the mechanical engineers there. And I thought maybe when you come out from school, before you are coming to learn this from Toyota or Hammond or where, or you go to China and go and learn and come back. So I'm thinking if like there's a way you can collaborate or future with the curriculum or the programs with the institutions. So after you came out as an engineer, you can even help, because a lot of institutions you go, there's a lot of professionals, different professionals who are heading maybe their transport department. What you are selling this to us. And if I'm heading what I don't have the background of this, how am I going to handle those that works under me? So I think say like there's a way we should go or you can. And concerning about the licensing, I want to see license training on EV vehicle. I don't think it should be something different aside our normal training that we do. But there must be a specification. If you are licensed to drive only EV, you have to state it on your license. So I think that's.
All right, so I think it's well noted. Yes.
So on the licensing thing, if you notice earlier, I was trying to recommend that indirectly because the experience of driving an EV is different. You heard what they said. There's a lot more to learn. They mentioned acceleration is very fast. Acceleration of EVs is far faster. So you move like, you see that you need experience for especially the drivers amongst us. If you go into a new car that you are not used to, you have to take about 1 minute drive and steady the field, to do whatever, even the braking and everything. EV is a different experience. You press and you can easily get an accident just because of that. So I agree with you that they need some licensing regime. Maybe, yes, they can add it to the existing curriculum. Yes, they can add it to the existing curriculum, or you can have whatever. Because the statistics show that the likelihood of an accident with an EV, because of that acceleration, is high. Because of that, you need to have some psychological orientation. And this thing is beyond what you are used to. So I agree with you. In terms of the technical universities, from what I heard, I think you were asking why, how we collaborate with technical universities. So if you notice, this program is by KN University and the Brahman is a climate compatible, but Sunyani Technical University is here. Old Technical University is here. So even in normal practice, KN University oversees the engineering of all technical universities in Ghana. If you take me, for example, when it comes to moderation of questions, when it comes to automobile engineering, all questions from technical universities come to my table. So we work with them. There are some aspects they are better than us. There are aspects we are better than us. So we can only work together. So for these certification programs that we have from Ebrahamo Energy Center, the execution has to be with them. It's a national program. It's not a KUST program. It's a national program. So they can pick our curriculum and enforce them at their place at no cost. They just go through what has to be done so that we have a uniform certification. And they have more equipment than we have, like Sunyani Tech has more equipment. When we see that, okay, for this structure, we will need this kind of way, we will move the training to Sunyani Tech. So there is no competition, we work together. Some of them even school at KN University. He like this from Sunyani Tech University, is schooling at KN University. And sometimes I also go to KN University, so we work together. All right. Can we answer your questions?
Yes, thank you very much.
Last one.
Thank you. My name is Frank. The EV cars, I think the battery is, one of the major components. And after about 8 years, you have to replace it, right? Or what happens?
So not
I'm asking this.
8 years is not replacement, 8 years is warranty. So the manufacturer is giving you assurance that your battery cannot fail less than 8 years. So if you use it well, you remember there were talks about 10% and you are still driving it on, or that reducing the lifespan of the battery. Okay, so reducing the lifespan of the battery. If you use the battery as the manufacturer stipulates, you are likely to use it for a long time, 10 years, 15 years. Just as we have engines, we have people whose vehicle engines are broken down 5 years or even lesser. Okay, and if you are lucky and it's under warranty, replace it. But we have people who have also 20 years and there has not been a breakdown, overhaul of the engine. So it depends on how well you are doing your maintenance and obeying the manufacturer's instructions.
So I was asking this because, in Ghana,
yes.
Most of the cars that we use are home use cars.
Yes.
Most of our cars, and even the home use cars are even brand new cars to some of us.
Yes.
So I'm asking this to know the maximum years that the battery can last. as compared to the ICE, because after 10 years and a home use car is being imported to me and I see it as a new car and I can use it for maybe 5 years and even sell it to another person. I want to compare that to the EV in terms of their batteries. So if you can answer to that, I will be grateful.
So for the EV batteries, in fact, a lot of the home use vehicles that we import in, most of them already have issues with the batteries. When a battery's lifespan, the charge cycles increase over time you are not able to reach the full charge. It keeps reducing over time. So most of the used vehicles we have, they come in with their batteries already in a good shape. I know of some hybrid vehicles, for example, you see the car is a hybrid, but it's constantly running on the engine because the hybrid side has a malfunction. So to put it in a fail-safe mode, then it constricts the vehicle to run only on the engine. So all these are the challenges with importing used vehicles. You understand? But once it's new from manufacturing, 8 years, you are assured it should not break down. If it does, it is replaced immediately. It's a new part. So you can just estimate that after 8 years, probably you might start having issues. Since the manufacturer says it, you can say that, yeah.
Okay, so if we compare that to hybrid vehicle, Toyota, I say Toyota is the master of hybrid cars. Because so the battery is 20 years and you have to replace. 20 years you have to replace. So that is why when they come here as home use, then it becomes difficult because importing the battery alone will buy another car. So that is why it's but for EVs, none of the manufacturers yet comes out with that kind of assurance. Like Toyota say for hybrid, 20 years battery replaced. They just say it like that. And then 10 years, after 10 years, you have to, after every 3 months, you have to boost charge. That's for the hybrid vehicles. I think I showed that in my slide. And there is a charge for that. So every 3 months, you boost charge. And the warranty for the hybrid is 10 years, and for EV is 8 years. But for the hybrid, Toyota comes out clear that 20 years replace the battery. So maybe I can equate that to the EV vehicle. But none of the manufacturers yet confidently say that after this amount of years, because for batteries, the number of times you are charging to degrades it. Okay, so far that is all we can say. Okay, it may not go beyond 20 years.
Okay, thank you.
Does it mean that we said
you had a question?
yes, in your slide, you said if they are reselling, the price is I think half of what? So does it mean that we shouldn't buy new used? We can buy yes. Because if other than that, then if I use and I don't want it to be, what do I like the way you ask that buy a cars and buy top up and buy. So what do you do?
So here it's not to say that don't buy home use. So the purchase of home use depends on the package. Okay, so if that is what can be afforded, these are the disadvantages. Then based on that, then you make the purchase decision. You make a free decision. But not
you must also bear in mind that the battery arrangement, the way it is, having it to replace is not an easy task. So when you see in my slide, see where the batteries are and all the seats are on it.
Yes.
Okay. The way the battery is arranged, the whole floor is battery.
Yes.
So having it replaced is not an easy task.
Yes.
So don't go in for home use so that you bring your car for me to replace the battery. First, you and I will import it at a high cost and you will pay for it. And my labor, I don't joke with it. It is as equal as spare parts.
Okay, so I think that last question I think.
That's what I was
So
coming
buy
to ask.
brand new.
Okay.
I think that's addressed it.
Okay.
About the battery.
Yeah.
Are we able to assemble some here in Ghana here, or we just have to buy it? If it's a new car, like what the lady said, maybe I buy the home use car and I want to change into a new battery. Can get the battery new to fix into the home use car. And I think he has addressed it.
Not yet.
However, there are some of the, like the old technology hybrids, you can rebuild the battery.
Yes.
The current ones we have now, it doesn't allow you to open the battery. So that's why they even give the ETA warranty. So the ones that can be rebuilt, you can take out the defective cells and then replace them. So that's what can be done. Okay. So just before I give to Doctor, there was a question that was asking about the consumption rate. So for 1 kilowatt hour of charge of the battery, that can run 5 kilometers. So you can do your mathematics based on what capacity of battery you have. Every 1 kilowatt hour runs 5 kilometers. So that's the general average consumption. Thank you.
Okay, thank you very much. Please, let's clap for him. Thank you. Okay, so we are on to the last session. It's not working. You're also operating with here. Okay, thank you very much. The last session, maybe 30 minutes, will be done. So just to do some advertisement again for the Kwame Nkrumah University of Science and Technology, we are willing to help train, I mentioned transport management because the EV fleet require a different kind of knowledge and wisdom to manage. Otherwise, you buy your fleet and within a year or two, they'll be grounded because there's a certain knowledge base. So the management of it is different. We have a lot of courses. So if you need us to organize the training for you, you let us know. We will send you a link you can fill. Now you are in the phase of budgeting for your institutions for next year. Please put it there. We'll come and train you. Or we can invite you. Usually when we invite you for the training, it will be at your inconvenience. Because we may ask you to either come to Kumasi or other places. And you have to seek permission or whatever. So please put it in your budgeting so that we can offer the right training for you. Okay. So we want to answer the question of why EVs. Why has it become necessary? Pollution has been mentioned, fuel efficiency has been mentioned, so I don't want to talk too much. Climate change, and then decreased dependence on fossil fuels. So some of the diseases, asthma, lung cancer, neurological diseases, cardiovascular diseases, are all caused by the emissions. Most of the diseases, WHO did some analysis here, and they found a lot of casualties as a result of emissions in Accra, to be specific. In Accra. So there are a lot of diseases associated, and some of the diseases are not instant. It takes a while. So most people don't know much about them. You see the obesity. It says African cities suffer from bad air quality due to old cars, motorcycles without modern exhaust systems. I've had this question asked to me. Say Africa is responsible for just 1% of the pollution in the world. Or less. Why should we be worried about this pollution? Well, you can say that for climate change, that Yes, but when it comes to air quality, the problem is localized. You are in Accra, you are breathing in. So you survive. You don't say that you are producing 1%. Well, you are in the 1% and you are breathing in. So that is the issue. We have Joyce Okanse from Energy Commission. She's in charge of the Drive Electric Vehicle Initiative. Can you give us?
Welcome.
Yes. So the whole Ghana, all the electric vehicle initiatives is in your hands. You will make a presentation. Maybe you would like to come and say something small, something small. Something small. Tomorrow you will present, but something small today. Oh yes, some motivation.
Hi, good afternoon, everyone. Apologies, I'm late. I was in another meeting. I don't want to have been said so far, but tomorrow we're going to talk about like fuels, charging infrastructure, and distribution substations. So I'm going to be here, and hopefully we'll engage more tomorrow. Thank you very much.
Welcome. Review man.
Okay, so in terms of polluted, in 2023, Ghana was 17th in the world for the city of Accra in terms of pollution. And these are the people in Africa that we are competing with. You know, this is a Nigerian picture we took. In many countries, it's difficult to even get the fuel to buy. That was what drove Ethiopia to go electric. The fuel was not even present to buy. So electric vehicle kind of solves problems like this. If you take emissions in Ghana, the latest statistics is 2022 statistics. Of all the emissions in Ghana, almost 50% is from the transport sector. So if you get rid of the transport sector, 50% of our pollution problem is solved. So this makes our training here very necessary. And if you look at emission comparisons of the various vehicles, in one of our research, we compared Kona, Model 3, Aura, E70, all these are electric vehicles, this one. All of them, then compared with Corolla and Vitz, and you see the difference in the emissions. We consider the grade emissions as well. That's why you have indirect emissions from the other vehicles there. Now, we say electric vehicles are far more efficient than ICE vehicles because in terms of energy, comparing an electric vehicle to ICE vehicles is like comparing 1 cedi to $1. What $1 can do is far more than what 1 cedi can do. So the technology itself of IC is inefficient. So you need fuel. For IC, you need fuel to come from the pump. The pump takes the fuel, moves it, goes through, if it is the one that uses injectors, goes through injectors, sprayed into the combustion chamber. At the same time, it must get a certain quantity of air coming in. If it is a spark ignition, it has to be a spark. It has to explode. Now, what's the problem? The problem is that you are asking for a lot within a short time. You need to get to 100 kilometers per hour from 20 kilometers per hour within a short time. All these processes of fuel, air, mixing, combustion, crankshaft up, down, all have to happen and give you the power within that short time. Because of that, internal combustion engine vehicles are at most 35% efficient. So what it means is that 65% of the fuel you buy actually is wasted. Then when it gives you that energy, the energy has to be transferred to the wheels. Eventually about 10 to 15% is transferred to so the rest is lost. So the process itself is inefficient. If you take the same thing for for battery electric vehicles, you have about 80 to 88% efficient. So only about 10% is wasted. That is where much of the gains come from. So you see the comparison that if you are using the same kilowatt hour, the BEV will take you to about 450 kilometers. and then the ICE engine will take you to about 76 kilometers. Okay. Now, another problem we've been battling with, I'm part of many committees, national committees. I've been on the committee with Chief Inspector. We do fuel standards for the country, fuel standard, vehicle standards. Chief Superintendent. Chief Superintendent.
Oh,
Sorry for demoting you. Please don't catch me on the road. This is out of ignorance. I know you say ignorance is no excuse, but it's okay. Yes, Chief Superintendent. So one of the issues we deal with is fuel quality, African quality. Too toxic for Europe, but fine for Africa. So you see, the emission systems they design for vehicles is very sensitive to the quality of fuel. If you have Euro 6 car, which are the tier rubbers now you sell? Euro 6D. D. Which of your cars matches that? Okay, Land Cruiser 300. You are rich, you brought it into the country. You are coming to show off.
There are 4.
Yes, there are 4. Okay. But if you get to the fuel station, you'll be humbled. Because the quality of fuel that car needs, you don't have it at the fuel station. So you have to import the fuel if you want. You know some people import fuel. Oh, I know someone with a fuel station in his house, specifically for his cars. So the quality of the car must match with the quality of the fuel. So if your fuel quality is Euro 3, indirectly what we are saying is that Ghanaians should import Euro 3 cars into the country. 1990-something cars should come into the country. So usually fuel quality is an obstacle. You have issues with adulteration, you have issues with refinery, Temawe refinery, I don't know what capacity, it's not up to Euro 2. So the imports, how to regulate the imports in Savlugu, Nyampo, and all those places is also a problem. It's Euro 2 now, yes. They want to move it to Euro 4, but it's Euro 2 now. So that one is also a challenge. Now, how is electric vehicle doing on the world? We want to know. So, in the world, about 4.9% of all buses in the world are electric, about 4.9%. 730,000 of them are battery electric vehicles. Plug-in hybrid electric vehicles, about 39,000 of them. As for electric 2 and 3 wheelers, 79 million units, and they constitute 9.2% of all 2 and 3 wheelers in the world. Cars, 4.5% stock share in the world, about 39 million battery electric vehicles, and then plug-in electric vehicles, 19 million units. Then vans, their penetration in the world is 1.3%, trucks 0.5%. So it's clear that this is what is going to be very difficult to electrify as we go. But as for 2 and 3 wheelers, I think 9.2% is significant. China, which is the leader, if you take China, 2 and 3 wheelers, they have an EV stock share of all vehicles in China. Electric 2 and 3 wheelers are 39% of all 2 and 3 wheelers in China. Europe is 2.6%. America is 0.6%. So 2 and 3 electric 2 and 3 wheelers are more popular in China and even India than Europe and USA. Electric bus, 30% of all electric buses in China are electric. 2.2% of all buses in China, in Europe, are electric, and 1.1% of all buses in US are electric. So China is leading there too. In terms of cars, sedans, and other things, 11% of all cars in China are electric. For Europe, the whole Europe, 4.7%. For US, 2.7%. Vans, 5.8%. For China, 1.5%. For Europe, 0.4%. For USA. Trucks, 1.2% of all trucks in China are electric. Europe, 0.4%. America is negligible. In Africa, you can see Africa is also taking off in terms of 2 and 3 wheelers all over the place. I'm sure everyone here has seen an electric motorcycle, scooter, or something. They are all over the place. Especially if you go to Tamale, Bolgatanga, most of they are 2 and 3 wheelers. And if you come to Kumasi, you go to, there's a place we actually assemble. They assemble
solar taxi. Solar.
No. There is this Zongo area where no Abu. They do a proper assembly, but nobody knows. They bring them in buses and they assemble all the electric two-wheelers over there. In terms of for Ghana, for 2024 data, I looked at the EV stock. In terms of 2 and 3 wheelers, the sales share, about 9.2% are electric. Sales share for, I'm not seeing the colors very well. Okay, good. So for trucks, almost negligible for 2024, 0.5%. Vans about 1.3%. The sales share 4.5% and 4.9%, etc. Now, if you look at market share for current market overview of the dealers in the world, those who sell, the manufacturers, BYD is top. They have 19.3% share in the whole world. Tesla is now 8%. Tesla used to be the highest. So BYD, as at February, no, as at quarter 3, BYD has sold 29 million electric vehicles. Tesla sold 1.2 million. Geely, positive 7.9%, VW 5.9%, SAIC Group 5.3%, and all the others put together everywhere, 53.5%. Now the e-mobility players in Ghana have increased. I just brought all this for you to know that it's increasing every year. Solar Taxi, Ijano, Wavu, Athletic Meridian, Plug Drive, Smart Transit, Drive EVGA, Lodok. Owner of Lodok was here some time ago, just a few minutes. Shark Express, EV House, etc. Now, what has been the case of incentives? Incentives have been announced at least twice, 2020 and then last year, incentives. So we've done some study on how effective the incentives have been and whether they were implemented. Mostly, the latest incentive was on buses, electric buses, that they will zero their VAT for them. When we went around talking to all those who bought the buses, they said they did not get the incentive. The challenge now is that not only are they not getting the incentives, it's more expensive. So they have an import tax component, which is a percentage of the cost of the vehicle coming in. For internal combustion engine vehicles, it's from 5% to 20%. So the higher the cylinder, like V8, you get 15, 20% tax. And then when the cylinders are less, you get lesser one. But when it comes to electric vehicles, they don't have cylinders. So I don't know whether it's because they don't know how to do it or not, but they put it at a fixed 20%. So you pay more tax with an electric vehicle, whether small one or big one or whatever, you pay 20%. Now we try to look at the cost percentage with equivalent internal combustion engine vehicles in terms of incentives. So the first, if you look, it said no incentive, it will be 63% higher in terms of taxes for an electric vehicle. There was a previous incentive, it just brings it to 59.58% higher than an equivalent internal combustion engine, 58.3. And then if they zero all those taxes, 51.2.4%. So in terms of incentives, a lot is not being done so far. Now, just the last thing to talk about is recycling and how to deal with EV waste. If you look at the diagram we have here, the major concern about EVs is usually about their batteries, because it's huge and all that. If you look at the minerals it's made up of, you have graphite, you have aluminium, you have nickel, you have copper, you have steel, you have lithium. Lithium is just 3.2% of the weight of the battery. So even though it's called lithium-ion battery, it doesn't mean that is the major aspect. There are bigger aspects of it. Aluminium is higher. Graphite is more, about 28% graphite, 18% aluminium. Nickel about 15%. Copper about 10.something%. Before steel, lithium, and others. So lithium is not that much. Now, what is the major problem? EV batteries are considered as hazardous waste. They've been classified in the world as hazardous. It's confirmed. Now, why? They have a tendency to cause fire. We'll talk about fire tomorrow because of their chemistry. Even when you throw the battery away in the landfill, there is no fire. In about 20 days, it can generate its own fire. Yes, because of the chemistry. It can produce oxygen by itself. So it doesn't need the air. Produce the oxygen, produce the heat by itself. So tomorrow we will learn that even in putting off EV fire, you don't target the fire, you target where the oxygen production is. There's a way to handle EV fire. And sometimes it takes days to quench the EV fire because it's generating the oxygen and it is burning by itself. Tomorrow you will see that. Tomorrow I will show. No, it doesn't occur often. But there's a way to manage it. That is all. Please, I hope you understand.
Yeah.
I'm not saying there's a way to manage it. So if you understand it, and you go you look for where the fire is, you are putting it off. The thing is as you are putting it off, it's generating. So it's a way to handle it. There was a situation where they put off the EV fire. It goes off. They put it in the tow truck. The car was being towed. About 2 hours later, it started in the car, burning again in the car. They stopped it. They arrived. It started again. So it is not good to dump the battery in a landfill. That is one. That is why it's classified like that. Then it has, because it produces its own gases, it does what's called toxic leaching. It produces liquid soup. So when landfill, batteries can leak heavy metals like cobalt, nickel, lead, and harmful electrolytes into the soil and groundwater, polluting the ecosystem. Batteries mixed with regular trash can cause severe fires in collection trucks, sorting facilities, and incinerators. Lack of proper training in handling damaged batteries at waste facilities leads to accidents and injuries. So what are they doing in the world? I know EPA has some legislation in dealing with electronic waste. They have an act. They have an LI, they have an act in dealing with electronic waste. Very properly done and all that. But the problem will always be with implementation. So who is going to do they put the burden of recycling on the manufacturer and the distributor. Like Ijanu is selling EVs. They put the burden of the recycle. But does Ijanu have the capacity to recycle the batteries? That's another problem. The Act also states that there should be specific plants by the government and also by private entities to recycle. We don't have such a single plant yet. But what is being done in China is that, for China, it's compulsory that, for example, nickel, 98% of nickel, cobalt, and manganese be recycled from EVs. It's a law. More than 85% of lithium ion should be recovered after the end of life of the car. More than 97% of rare earth elements and all other metals should be recycled, and they have assembly plants for that. If you go to Europe, they also have specific dates with percentages that should be recycled. So what we may need a national battery mandate. So, for example, they don't allow battery waste to be collected together with certain waste. It's written on the battery where the battery should be sent to at the end of its life. Containers and who has to handle it, all those things are done, and we need such a mandate. Then, in terms of challenges, I've mentioned the high cost of EVs as a challenge. It was mentioned here in the morning. But there are green loans that are being used to distribute EVs. Energy Commission had a green loan. I've forgotten the name of it. Joyce, do you remember? They have SunRev, which has a green loan. Then EcoBank and the others also have loans at very low percentages. I'm told single digits percentages to buy electric vehicles, etc. Now, in terms of the challenges, EV training is needed. For example, fire service, they need to be educated. 3 days ago, I read that Technical University of Munich has come together with their fire service to foster collaboration in how to put out EV fires. So it means there's still a lot that needs to be learned when it comes to EV fires. So there should be collaboration in how to put out EV fires. The police should also be trained, because sometimes, even when we need a fire service person, we call the police to arrive first and figure the rest out. Ghana Revenue Authority, they need to be able to identify EVs, if there are incentives, to know how to collect it, to apply the incentives properly. DVLA needs, because with the advent of electric vehicles now, there is a new way to test EVs for roadworthiness. It is never the same as the conventional vehicles. So they will need retraining, first on how to identify it, and then how to assess their roadworthiness. And they have to be trained and certified for that. Then Energy Commission, and then safety training of repair. So you go to an EV repairer who doesn't know how to manage batteries, is going to cause a problem. How to even dispose it of, the person has to be trained. So we need skills. There's a huge skills gap in training, which KNUSC is trying to fill, and then we need a recycle and disposal mandate. And we need to limit second-hand EVs. I think if there's anything you should learn today, I think you should learn that it's not the best decision to buy used electric vehicles. It's not the best decision, because the battery has a lifespan. And even that, tomorrow I'll talk about that. Even if they say the battery lasts 10 years, depending on the use case, it may not get there. Depending on the temperature in your environment, it may not get to that 10 years. And now you have a vehicle that's already 5 years. You don't change the battery before it has arrived. It's a rubber for you. It will not last long. I had a colleague who had to change a hybrid battery, and he eventually had to import the battery to change. So I think going forward, the advice is that we should focus on new EVs so that we can. But the good news is that the batteries can be repaired. We are developing competencies around that. The batteries are made up of cells. So The EV technique, the battery technician is able to detect which cells are defective and replace those ones and do balancing. They also are able to balance the cells as well. So what policy makers like you should understand is that e-mobility is an energy transition. It's not just about cars anymore, but it's about the grid. So NEDCO, ECG, GRIDCO, independent power producers are all stakeholders in this. Tomorrow I will be telling you how much it will cost the grid, or how it can affect the grid in terms of demand. If all of us were to own an electric vehicle like we own conventional vehicles, and so there is preparedness that has to be made. Skills acquisitions should be formalized. Already there is a challenge in skills when it comes to mechanic training in Ghana, not just about electric vehicles. There's a challenge. Skills in that area is not formalized, it's informal, so more like an apprentice. So the level of knowledge keep different. If you have somebody who was an apprentice for 6 years, now master mechanic, but maybe during the apprenticeship, the person didn't pay much attention to the 6 years. The chances you ruin your cars are very high. Then you will have somebody who pays much attention. So it's very varied. We need to find a way of formalizing it, which is what we are trying to do, where the competencies are formalized. And if you formalize it, you are able to retrain people with new, when new technologies come in. Like Toyota, he's from Toyota. Every year they take him to Japan to train him. But this guy has been fixing cars so many decades ago. But every year they take him. So what else does he have to learn? So what it means that there's a new technology he doesn't know. They have to take him, train him, and bring him back. And so if we have formalization of technician training, we can easily update the knowledge of technicians. The transport management, like I said, needs to change to integrate EVs. You have 5 buses, electric buses, and 5 ICVs. They are different. The ICV can fuel in, is it 2-3 minutes? Can fill up. The BEV bus cannot fill in 3 minutes. So does it mean there's a point that is going to come, you are going to arrange all the buses? Maybe you have one charging station, you will be waiting the whole day to charge. Yes, so you need plan management around it. So that while this is charging, this is working, this is working, this is charging, this is working, and then you have the whole 24 hours working schedule. And there's a way to do that. So we need training. We need regulations. The regulations must be anchored in robust data through research, inclusive community and engagement, sound financial analysis. We need a managed and deliberate phase out of fossil fuels. Let me bring one issue up. So usually in public, policymakers will usually advocate for EVs, but in private they have concerns because somebody is working at the Petroleum Commission, somebody is working at Energy Commission, somebody is working at NPA. Everything's about fuel. Is that not the case? Yeah. To take it away, what happens? What are we going to do with that entire workforce? And Ghana is now that we are draining the oil to enjoy some dividends. And just when we started, you say we should stop. Yeah, so realistically, it is an issue. So privately they will talk, publicly they will talk, but privately they will tell you that you enjoy this petroleum, we just started and you want us to, and it's realistic. So we have to look at a realistic way of transition. If you take, I was examining the taxes on fuel yesterday. We have more than 6, 7, 8 taxes on petrol and diesel. Now, if we throw all that, look, road funds, the tax is on fuel. Energy stabilization levy is on fuel. ESLA is on fuel. Sanitation money, they put it on fuel so that they can get it early. What else? So many things. So now if we shift everything to electricity, does it mean all those taxes are going to push to electricity? And how do we manage it? We need to have a real conversation about it, because Daniel Sir from Ministry of Transport will come tomorrow to tell you about the targets for EV penetration in Ghana. And they are targeting that from 2045, if the car coming in is not electric vehicle, it shouldn't come to Ghana. So I can also say maybe then from 2045, then NPA people should find another job. Is that not it? Yes, that is what it means. So we need to have a real conversation on how to transition. If we avoid conversations like that, the transition will never happen. Okay, thank you very much. Any questions? Any questions? This is the end of our
Mine is a
session.
comment.
Okay.
Is it the last station that was done, the issue of, and you keep on talking about policy and legislation. I think on the currently, they just laid the road traffic bill that just been laid today. We only have a amendment to allow for EV vehicles to have their number plates. So physically you see how it will evolve in terms of its presence on your road.
EVs will have a different number plate.
Yes. So that is one. That's the idea. Yes. We will identify it for research and other people to know that. But the issue of enforcement in terms of disposal of hazardous battery, for example, and handling, so that it will not turn into Motia battery as in the legislation. There is nothing into the committee is working, but nobody brought it. And I'm faulting DVLA, for example. I'm faulting EPA, for example, and the Transport Ministry, for example, and the Energy Commission and all that, because the policy exists and all this information is there. And I'm wondering why is it that the committee just rules what it has been laid. Okay. So police will very likely be handicapped. For example, and you see such batteries and all that's being disposed of in a manner that can cause a lot of hazard. In the airline, there are ways of handling hazardous goods. Okay. So other than that would have been amended to define, include those parts that when exposed to or transported in whatever, they will handle it, but that has not been done. So I think there is also a way for yourself and other institutions to come up as the airline comes out, matures. The next sitting of the committee, some of these things will come for consideration, because in respect of what you are saying, the Gen Zs will go for it.
Yes.
And it's just pure competition. Nobody can stifle it. It's a scam. And so state will also find alternative use for these fuels and allow these batteries and other things to be also. So for me, there's a gap and we have to go back to work. And I also add to advocacy. Thank you.
Thank you very much. So the Road Traffic Act, is it final now?
No, it's late.
It's late.
Yes. So that is
Some of us have
but
not seen
the regulation can always be amended anytime. You understand? The act takes a long time to, but we don't need to amend the act. It is the airline. So though the airline will mature, next year we can go back because it's critical. I'm afraid of the way that battery can be. You can imagine, and that's why we are recommending that you don't think we should allow for use once coming in. Because the battery.
I think to add up, you made mention of fire service. in terms of this training. But I think, like Supo said, the policy document that was last year, they wrote out that we had, it doesn't have anything like fire service even included in it.
Oh,
Yeah,
okay,
so-
the EV policy.
Yes, so I've gone through it and I've not realized, I'm not seeing any fire service. But what you said is very important. So maybe as part of what you said, we can also note it down and take it down. Yes. Thank you.
Thank you very much for that.
Okay, I would also say, I realize, we are promoting the use of EVs and to buy into the idea that EVs are coming to school. Now, and in the morning, we're also giving the information as in the percentage of import tax on EVs. So automatically it's discouraging to say that, but already the cost of the vehicle is high, and then imports is also high. Now, Energy Commission is promoting the use of EVs, where there are funding to Energy Commission to promote it, where they are coming on with all infrastructure. So where is the collaboration between the government, because Energy Commission in itself is also a government institution, and it is promoting it. So who is funding the idea that we should promote that, and then we are also punishing us with tax?
So Energy Commission and ECG actively promote the use of electric vehicles. But ECG wants you to consume electricity. Pay for it.
So they are actually supporting it. But African governments are very skeptical about electric vehicles because they want the fuel thing. Their revenues, percentage of fuel revenues comes to Ghana, and we do a lot of things with it. Yes, I'm trying to be realistic with you. Yes. So they haven't been able to synchronize how we will recover revenue if petroleum sales slumps. This is realistic. If you are the president, you'll be thinking this. Yes. So they are very skeptical. Otherwise, there will be incentives all over the place if they were not that skeptical. So we have to find a way of helping government to recover whatever they will lose from petroleum fuel sales. I was checking the statistics, about 80-something% of fuel usage in Ghana is to the transport sector. So if you take away all that, where is the revenue going to come? Look at the all the OMCs, look at all these numbers. The OMCs fund a lot of projects in Ghana. So there is some skepticism that we are not ready, but let's allow it to go for a while and see what happens. That is the challenge. You yourself, you work at petroleum yes. So we have to find a way of, there are green skills that we can transition to, but people have to be retrained for that. That is why people like Boss have a green. Tell us about your green transition, whatever.
We have a new cycle of green transition and alternative sources. So we are looking at decarbonizing our operations, and then looking at also getting biofuels, blending that reduce emissions, and looking at a partnership with Joel, how we can enter the EV space, the infrastructure. So just like you said, we are scared about the future. Our primary responsibility is storage of petroleum products. And then with the advent of EV, that onslaught is why we have to wake up.
So they are re-strategizing. For example, ECG will not promote that everybody will have solar in their house. They will not promote that. They will not promote that. So some institutions are finding ways to re-acclimatize to the name. So don't expect any Even look, even if you take America, if you compare Trump to Biden, the approaches are different. President Trump says that we should go the whole way and forget these EVs because EVs cannot be used at war and so many things. So there are many approaches. Okay. Any other question?
So the other guy noted that overspeeding impacts power consumption.
Yes.
Okay. Meaning these vehicles can help rectify the human error pattern of road crashes.
Oh, you mean the bus? Okay.
Yes, the EVs.
You understand the question? Okay. Yes, go ahead.
Okay. So what collaborative strategies can your company and National Road Safety Authority implement to mitigate road crashes in Ghana?
Okay. You want to answer?
Yes, just
start and then I'll finish.
So I think there was a comment that was made that the vehicle will teach you when it comes to speeding over time. The reality is that when you do sports driving with an ICE engine on a normal road, you definitely also consume fuel. So the EV does not necessarily restrict you from overspeeding. It is actually more dangerous. However, vehicles have speed limiters. So ICE engines currently have speed limiters. Some of them, they wouldn't allow you to go beyond a certain speed. It's preset by the manufacturer. And there are others too. You can have other auxiliary devices installed to give that kind of effect. So it is not, it shouldn't be assumed that EVs, once I think the Geely EX5 has a speed limit of 175 kilometers per hour. That is how the car was designed. Well, that was how it was designed. So you can't go beyond that. But if let's say it is 240 kilometers per hour, once you step, it will go. Yes.
So most EVs have their speed, the highest speed is not very high compared to ICE. Most of them. It's a bit low, especially for buses. Sometimes 70 kilometers per hour, 80 kilometers per hour, and it is done. But in terms of acceleration, the chances of accident with an EV is higher. Yes, it does not tolerate so much of indiscipline. Yes, because I mean, it's a motor connected to battery. Motor needs energy, battery gives it, it moves. By internal combustion, fuel has to go air combine, do this before. So,
sorry, I just wanted to explain the meaning of what he said. You know, even in this new ICE vehicles, when you are driving, it gives you your fuel per 100 kilometers, how much you are using.
Yes,
and the consumption. When you are driving and you notice this consumption, you see it going up, you'll be forced to reduce your speed to drive within the economical speed. And it's the same thing he's talking about the EV, because as you drive, you see your battery going down, and it will push you to slow down within the economic. So that's what she's referring to, what he said.
Oh, okay. Okay, but I think in summary, drivers need to be trained about this. They should. I had an experience where I had a lady TA in my workshop. I have a workshop at KNUST.
We build electric motorcycles, cars, and all that. So she knows how to drive motorcycles very well. But she hasn't driven an electric motorcycle before. The first time she tried, there was an accident. It threw her over the road. Yes. It threw her somewhere. Only God saved me that a car did not pass over her. She underestimated, because the moment she pressed the thing, it just went like that. So drivers need to be trained and be sensitive towards this. That's what we can do with National Road Safety Authority to avoid a lot of these accidents. Training. Have we answered your question? Okay. Any other question? Okay. So I think we have come to the end of yes.
Any of the slides going to be shared?
Okay. So as per standard
training sessions. We finished the 2 days and we sent all of you the slides and your e-certificates. The e-certificates is for those who came face to face today and tomorrow. If you miss one day, you don't get the certificate. So at the end of tomorrow, some of you will start receiving the e-certificate tomorrow, and we'll put the materials together for all of you. The idea is for you to give you the materials to retrain your people wherever. So by all means, we'll give you. And if you need more, you contact us, we'll give you. Okay, so I think we have come to the end of today's proceedings. Tomorrow, as you can see from the agenda, tomorrow is going to be more exciting. Yes.
I saw in the EV vehicle, there's no space for spare tires. The one we just saw over there, there was a space for fire service, fire extinguisher, and other tools. But there's no space for.
Did you look at the route?
Yes.
The back?
There should be.
There should be.
Sometimes.
I will let the EV drivers answer tomorrow. So it means for that particular model, when they come, we'll ask. Because if anything at all, there's more space in an EV than. So tomorrow we'll be looking at mid-busting sessions. Our electric vehicle says we'll talk about fire. We'll talk about the consumption. We'll talk about the range, highway traffic. We'll talk about the efficient speed for driving EV, efficient temperatures, air conditioning. Does EV batteries last forever? EV is more prone to fire. What happens when they are submerged in water? What happens accident? What are the precautions to take? If you are towing them, what precautions to take when towing them? Then we will look at charging system. Daniel Reset will be here to talk about the EV policy. Energy Commission will also be talking about the electric vehicle regulations, which Yours Truly is leading for them. And then EVs and the grid. Does Ghana have the power or energy to support the transition to electric vehicles? So tomorrow will be more exciting than today. Please come early as you came today so that we can finish early. We have one last thing to do. We need to take a picture, then you take your lunch, then you go. The picture people. Yes, where are we taking the picture? We will send you all the pictures we take, we will attach and send all of them. Out when we go down. So we need things in our back. We need Okay, so we take the pack, we go down there, we take a picture and we go home. Thank you.
I just wonder. Is it the same pressure price? I beg you, send give me when I go back.
I said no.
So how much?
It's all bad. I hope I mean
Let me say, Ghana, Arabic, and that's Arabic noodles. Maybe Arabic woman. This is when no one.
Go back up now. For sure, wife.
The distance is not clear there.
That kind. Hey.
Please, we are going now for the pictures.
Down.
Take your pictures. Let's see. There's a way to pull it down. They have something in place.
The president is there. President is there.
Oh, okay. And you are there.
I'm the road safety.
The road safety, okay, that's nice.
Well, yours, let me put it down for you.
Yes. Are you coming tomorrow? Yes. Okay, so let's. Yeah.
It's your
Yes. I was thinking that I just know about that. I now understand. If she really saw that,
Yeah, we.
I now understand why she was fine.
This is the motorcycle, the whole Ghana. I know all this. Yeah, we will be back. I will see you.
Do you know where Prof kept my food? I think it should be here. All right.
Okay, then I'll see you tomorrow. Bye. Thank you very much.
Attendance, thank you. The pen. Ah, oh, sorry.
Thank you.
I've done the rest.